Hello everyone, this is Shatrupa and welcome to Campusmonk. So this video is going to be pretty interesting. We'll be discussing about the Infosys DSE and SE roles. We'll talk about the syllabus, we'll talk about the time, we'll talk about the test cases that you have to pass, we'll talk about a lot of things. So let's get started with this. The first thing that I want you guys to know is that you will have total of 3 questions. Each question will approximately have 1 hour time limit. So your difficulty level will be different. One question will be easy, one will be medium, other one will be hard. So basically it's going to be either easy medium or it will be medium hard. So it completely depends upon luck, I would say. But yeah, these are the 2 categories. Mostly they try to stick to easy medium. They do not usually give this, but yeah, at some slots or some time you do get medium hard questions. Okay, so approximately you can allocate 1 hour for each question on an average if you just consider that roughly. And yes, your sections will have cutoffs, so definitely will have some cutoff for this particular coding section as well. Okay, so what will be the cutoff? It will be the percentage of test cases that you pass. We'll see that later in the video. Okay, so you will have coding round. So definitely there will be 3 questions like mentioned earlier. One will be easy, medium and hard. Not necessarily in this order that the first question is easy, then medium, then hard. It can be in a mixed up pattern. The first one may be hard, then easy, then medium, in any order. But just suppose that we have easy, medium, hard as the order. For easy question, should not exceed more than 30 to 35 minutes. Keep that in mind. Why? Because once you figure out that you're going to use an array or a string or it's a simple sorting question, just go for it. There's no point in wasting time, no point in covering up things that are unnecessary. Okay, the next one, definitely if it's a medium question, do not spend more than an hour on this. Okay, why do I say this? Because when it comes to hard question, people usually start to panic. Okay, because we have already wasted our time mostly in this easy part. Okay, for hard, definitely you need to allocate around 1 hour, 1 hour 15 minutes. It's must. Okay, otherwise it's going to get complicated. Few things that I want you to remember while you solve this. First one being, read the input output format. Okay, what is the input output format? Okay, then second, read if there are any constraints in the question. Okay, if not, fine. Third, do the dry run. Okay, dry run is must. Once the dry run is done, you need to write your pseudo code. Okay, and once the pseudo code is ready, you need to make a comparison between your pseudo code and your dry run, that they are matching. If not, edit your pseudo code right here. Okay, then do your coding. Once you're done with the coding, if it's running, fair enough. If not, you are only going to compare it with the pseudo code. Do not try comparing your code with the dry run. It will confuse you. Okay, so that is why it is important that you validate your dry run with your pseudo code. So if you encounter a coding issue, make sure you always cross verify it with the pseudo code and not with the dry run, until and unless you cannot figure out from your pseudo code that are you arriving at that output or not. Okay, what is important is that you need to keep in mind what your input output formats are. Do not write like enter name, enter age, enter this, enter that. No, who's going to enter? It's a system that's going to run the test cases, right? Just how it happens in lead code. So you do not write those print statements. Okay, even in your output, do not write a print statement, simply print it, right? Moving to the next thing, that would be, what kind of question will you get if it's an easy level? First, it will be either arrays, strings, sorting, searching. Okay, these kind of question in easy level, the basic data structure. And for this, 30 to 35 minutes is pretty apt. You don't have to actually spend more than that. Next is your medium level, where you come across heuristic problem solving. That means you're having an array and you probably have to implement another data structure on this array, and that is known as heuristic, where basically you need to optimize. Okay, the concept of optimize. So for that, you have recursion questions, you have binary tree, you have greedy algorithm, you have heaps. Okay, these are the set of questions, and it is fair enough to spend around 45, if not 45, let's say around 50 to 60 minutes on such question. Fine. Okay, then you have your hard level, which is usually dynamic programming. You don't get anything other than that. But along with dynamic programming comes something called as backtracking. So definitely you can get a question from there. You can get question from graphs as well. Graph is one of the most complicated data structure. So yeah, you can get definitely questions from here. Okay, so later in the video we'll be solving a lot of questions. We'll come to that on the later part. But these are the kind of questions that you should prepare before you onboard on the exam. Okay, so how do you know that if you have cleared the test cases or not? Okay, so basically you will have your questions. Suppose question 1 is easy. If it's an easy one, then you need to make sure that you clear all the test cases if it's easy. If it is medium, 80% of the test cases will do. Okay. If it is a hard question, not 70, but I would say 70 to 75% test cases will be fine. Okay. So these are actually how the cutoff will be calculated. Okay. These will be your cutoff for the coding round. So moving to the kind of language that you can use. So you can definitely use C, C++, Java, Python, JavaScript. Okay. Now, you can use multiple languages. What I mean by that, suppose you're solving question 1, which is an easy question using, say, C++, okay? Now, in the medium question, you feel that, okay, no, I cannot do it using C++. I would rather use Java over here. So you can do that. In question 3, it's getting harder, right? So you would prefer using Python because it probably has some inbuilt functions or something. So you can do this and no one will judge you for that, okay? So you can use multiple coding languages in your single coding test. It's absolutely, completely fine, okay? So we'll move on to the question set now. From here on, you will see a lot of questions that we will solve in Python and in Java. Okay. All I want to say for all other students that are using programming language like C, C++, and JavaScript, the overall logic will remain the same. Okay. If you have understood the logic, because I will be explaining it before I start coding. So if you understand how I explained it and what we are actually doing, then I guess if you get the logic, you can code it in any language. It's a matter of syntax, right? So we will be seeing questions from arrays, strings, some heaps. We'll see something from binary tree or different data structure. We'll have recursion and everything. Few questions will be from lead code, hard, medium, and few will be actually the previous year questions. Some will definitely be questions that I have prepared, some that are relative to what you can expect in the exam. All right. So without wasting much time, we should get started with the question. Today we'll look into a very interesting question that was asked in Infosys for your uh, positions that you're looking forward to. Can be like DSE roles and SP roles. So if you want to crack those, I guess this question will come really handy if you understand how to solve it. In general, if we view this question, this is more like a very common kind of a question that is asked even in interviews. So it's a little tricky, but not that much once you understand it. So it's basically telling you that you are given a string that is numbers. Okay. So you basically have numbers as an input, but it is in string format, representing a positive integer and a character digit, right? This is a digit, it has just one character. I'm sorry, I guess we are missing the quotes here. Okay. Return the resulting string after removing exactly one occurrence of the digit. So now you have this digit 1. You have to remove one occurrence of this one. Okay, exactly one, not more than one. If there is just one occurrence, fair enough. If there are duplicates, repetition, like in this question, you need to remove just one, such that the value of the resulting string in decimal form is maximized. Okay. The test cases are generated such that the digit occurs at least once in the number. Fair enough. So now you have the number 1, 3, 2, 1, and your digit is 1, right? So which one will you remove, this one or this one? Mind you, there is a condition given here that such that the value of the resulting string formed should be maximized. That means if you remove this, value will be this. If you remove this, your value will be this. So which one should you remove? You should keep this. That means you have to remove the first one, right? That is why your output is 321. So how you basically executing this? A very straightforward approach. So you have this as your number, right? This is the index 0, 1, 2, and 3. Now when I divide this, okay, at say I is equal to 0 at this state, okay, what will be my value? My value will be 321, right? And when this is for this. Now if my I is equal to 3, I mean this part, if I remove this, what will be my value? My value will be 132, right? So how am I going to run my loop? I'll basically do, say, n is the total length of my array. I'm going to run it from 0 all the way till I. Okay. Along with from I plus 1 all the way till the end. Even if you don't write anything, it's fine. Even if you don't write 0 over here, it means it will start it from the max. Okay. So here in this case, it will be n of 0, because your I is 0, all the way up to, what is your I plus 1? 0 plus 1 is 1, all the way till the end. Okay. So you're going to run this. This is the only condition that you're going to use. Now, if we go back and we'll just try coding this. So I'm going to hard code this, but I want you to try to take user input and do it because you won't be allowed to basically hard code it in the exam. So just try taking user input. If you haven't watched the videos of how to take in user input, please go back and just have a look in how we take user input for any exam. Okay. Suppose I have a digit D, which is equal to say 1. What will I store this value in? I'm going to store this value in a list, okay, as an array. So I'm going to run my loop I in the range. What will be the range? Definitely till the length of whatever your n is, okay. Now we are going to check at every iteration. We'll check if my n of I is equal to what? To my digit D. Then what am I doing? I'll take a variable t and I will write down the exact condition, that is 0 all the way till I, then plus you will have n of I plus 1 all the way till the end. Okay. And what are we doing? We are simply appending this to our answers list. Okay. You can simply append t, but just to make sure that we are properly typecasting it, I'm going to do int of t. Okay. Now you go ahead and print. What will you print? Definitely you need the maximum value. So you need to print it as max of ANS of the answer, right? But since it's in string format, make sure you still have your answer in string format. Okay. So these are the small technicalities that you need to check while you're writing your online test. Okay. Correct. So instead of this, if I had to change it, what would I do? I would just say int input. Okay. And say, suppose I take int input here as well. Okay. But you must be wondering, why did I take int? It should be str, right? Fair enough. It should be str. Okay. So you need to enter it as an str and you got to run this. All right. So suppose I enter 1, 3, 2, 1, and then I enter 1. It's still going to return you the maximum. Okay. So this is exactly how you're going to do in your exam. You're going to take user input, do not hard code it. Okay. That hard code was just for an example for you. Okay. We are going to do the same code, but we'll use Java for this right now. So it's going to start with definitely the main function because I'm using an online editor. And if you are using some IDE of your own, that's absolutely fine, right? So we'll have the public static void and main, which will definitely have your string arguments that is being passed, right? And rest of them is mostly the same thing. Okay. Why is it the same thing? It's the same logic and everything remains the same, right? So I would insist that I'm going to take a direct hard coded input, but try taking it's your responsibility to take a user input and try this question. So if I have n is equal to, we'll take the same number, that is 1, 2, 3, 1, and we will take the same character also or the digit. Let's say we are going to take 1. Okay, I guess it was the same thing. And we are going to basically return the max. So it will be integer dot min value. Okay, so we'll now run the loop. It's going to be the same loop that will run from int I equal to 0 to all the way till I is less than n dot. We'll take the length, whatever the length is, and we are going to do I plus plus. Okay, now once this is done, you have something called as the comparator, that is the if. So you're going to compare your each character or your each digit in this case at I. If that is equal to, I'm sorry about the capital. So if that is equal to your digit, okay, then you are going to basically create a temporary string and we will call that temp. And what are we going to store? We are going to basically store the substring of it. So n dot substring. I guess I went to down. So yeah, substring, and we'll pass it from 0 all the way till wherever that I is, wherever it is matching, along with it will be n dot substring. Again, what will you add? You will add I plus 1, right? That is all. Make sure you don't miss out on any semicolon. That is very vital in Java. Now you're going to take another variable called val, and you will do integer dot, we'll parse that number first. And what will be passed? The string that we stored, that was temp. And now we will do a comparison again, that if your value, okay, if your val is greater than your max, okay, if that is the case, then what are you going to do? You're just going to simply assign your max to be equal to your value. That's it. Okay. Now, once you're done with that, you're going to come out of this for loop. Once you're out of that, you're going to just return. So you will do system dot print. I'm sorry, I missed out dot print ln. If you want ln, it's fine. If you want to do just print, that's also fine. So we'll basically do the value of your max. Okay. And that's it. So if I go ahead and run this, it is actually returning me 231. Okay, because it has to return the max. So if it returns 123, then it will be smaller. So what will be the greater value? 231. So it's returning 231. I want you guys to try this question using user input. Try taking user input through the scanner class and let me know how it goes. Definitely it won't be that complicated or difficult, because this internal logic will stay the same. Okay, you just need to change these two things from direct hard coded input to user input, right? Hello everyone, this is Shatrupa and we'll be looking into another Infosys level question for the DSC positions. So this one is again a very straightforward and simple question, but people make mistake. The reason being they get confused in what the question is trying to say. All right. So if you look into this, it says that you're given an integer n. Okay, you're just given an integer n and you have an zero indexed integer array called nums. What does this means? That means your nums, the integer nums, all has been initialized with 0. How many elements? N elements. You're given an integer n, okay, of what is the length? Of n plus 1. Fair enough. We'll put this up as n plus 1. Okay, this is the first line. But how do you generate this array? Following these rules, okay? That means your first element of the array will be 0. The second element will be 1. Okay? Now, the how will you find the next? So if you look closely over here, it says I into 2. Now, if I is 1 and I multiply it with 2, what will be the value? 2. If I is 2 and I multiply it with 2, what will be the value? 4. If I is 3, I multiply it with 2, it will again be 6. So that means this condition is given for even index. Okay. And this condition, I guess it's missing 1 plus 1 over here. Okay. So this one is basically 2 times I plus 1. Okay, if that is the case, this is for the odd index. Okay, even index and odd index. Now people confuse here. When there are constraints given, it's basically starting point and the end point that you need to worry about. Rest you can ignore. Okay, now this is 0, this is 1, this is index 2, 3, 4, and so on. It will continue. Suppose our n is given as 7. Okay, so now what is your I is starting at 1. Okay, so you have your index field. So if your I is 1, then 2 times 1 will be nothing but your nums at I, whatever the value of I is. So it will again replace it with 1. Now this is odd, right? Index is odd. So we'll go for this fourth rule. So what will you substitute it here? So it's basically going to be 1 plus I, that is again 1 plus 1. So this will be 1 plus 2, right? That will be filled with 3. Okay, so like that way you're going to continue solving this. Okay, so let's go here and write this down. So we'll take your if you want to better understand this, you just need to return the maximum. Okay, I didn't write down the input and output. So basically whatever array you will generate here, whatever array will be generated here, suppose n is 3 in this case, whatever array will be generated here, you have to take the maximum. So what is the maximum value? 3. 3 will be returned. One thing here you need to take into consideration is your minimum value of I has to be 2, because if it's less than 2, that means it's the base cases that you have 0 and 1. Okay, you're basically not doing anything. So it needs to start with 2 at least. One more thing, when you take this space, you need to keep in mind that you are solving for the next two places. One is even, one is odd, correct? So you should always take a little more space, because your array has length of n plus 1. That means should keep something extra. Why we'll keep extra? We'll see that shortly while we do the code. Okay. So suppose I have the value equal to 7, and my ARR, as mentioned in the question, should be all initialized with 0. And what will be the length? It will be n plus 1, right? This is written in the question. What is my ARR of index 0? This is 0. And ARR of index 1, that is equal to 1, right? Now I have to run a for loop. Okay. What will be the range of for I in range? Now I will run all the way from 1, n integer division of 2 plus 1. Now why did I do this? Because we are running for both even and odd. Okay, since we are running for even and odd, we need to figure out n by 2, whatever the value is. If it is a whole number, then if you divide it and it's perfectly divisible, then you are not going, it's a even number, else it's an odd number. Okay, so that thing. Now we are simply going to write down the uh, rules that was given in point number 3 and 4, that is ARR of I and ARR of the other one was I times 2 plus 1. That means that will be equal to ARR of I plus ARR of I plus 1. Okay. Now this is all that you have to do for this whole question. The question looked complicated, but the solution was just 3 lines. So now let's just print ARR and see what we get. Okay, so we got the thing. Now we need maximum of this, right? So if we need maximum, what will we do? We'll put it up as max ARR. Okay, so you see you got your ARR and your maximum of all of these is 3. Now this is executing fine. So why did I mention that we have to take input as little extra space? Suppose I do it for 4. This will give me list assignment index out of bound, because it cannot assign that value. How can we resolve this? There are multiple ways of resolving it, but one way that I find is the best fix is if I just increment the size. Okay. If I just increment the size to, if I have extra space, it's fine. Doesn't matter. They all will be filled with zeros because it's an array data structure. So it's going to fill up the n places and they all will be filled in 0 thing. Okay. So which is fine. I don't really care about it. So if this is not being filled with your zeros, that means you can, that is why we are exactly initializing it. Okay, but if you don't have extra space and this is exactly till the length of what the question has been said, that will give you an index out of bound error. Okay, so yeah, this will give you index out of bound error for even larger numbers. Okay, so you need to be very careful while you allocate the space. Definitely there are better ways to solve this, but this is one of the way that I think I'm comfortable with solving. And if you have better way, definitely go ahead with it. I won't stop you. All right, the time complexity of this will definitely be big O of n, and space complexity is a constant. We aren't storing anything. Or actually we are actually storing this n thing, so that this is again debatable. Okay, it's a part of your return. So if you want to return, consider that you're storing it and all. So yeah, it's n. Otherwise you can consider that to be a constant. All right. So this is completely up to you. And that is all for this question. Wasn't that difficult? Just a little tweaking here and there, and I guess you are good to go. So we are going to see this question in Java as well. So how will we start the code? Definitely, it's a Java code, so you need to have your main class. I am using an online editor. If you are having your own IDE, please feel free to run it there. So we'll have static void main, and then we'll have the string, right? We'll have string args, the arguments. Once this is done, again, I'm hard coding this. I recommend try taking an user input, so that will help you better understand this question. While there's no difference in the logic, I still recommend that try out on your own how to take user input. Okay. So we are going to create the array. And how do we create an array? So basically, we have to create array objects in Java. So this is exactly how we create it. Now, we are already given that ARR of 0 is equal to 0 and ARR of 1 is equal to 1. Okay. So we are going to just run the loop like int I, whatever you want to take your variable, looping variable to be. So it will be set to 1. And where will it run? It will run all the way till less than equal to n by 2. Okay. And similarly, your I will be incremented. Okay. So now once this is done, you will enter and you have to execute the given queries that you have. So if you do I times 2, that will be equal to ARR of I. And if your I times 2 plus 1 is less than equal to your n, then what are you going to do? So you basically have to execute the other query that was given. So that will be I times 2 plus 1, which will be equal to your ARR of I plus ARR of I plus 1, right? So this is your major chunk of the code. So once this is done, you are going to come out of that and you are going to work on your max because you have to return the max. So max will either be equal to ARR of 0, okay, because yeah, the first index initially. Then you are going to iter over the entire given array that you have just created, which will be equal to I will initially be initialized with 1 definitely, and you're going to move, it's going to be the same loop, okay? And then you will do I plus plus. Now within this loop, you're just going to do a small comparison if your ARR at I is greater than your max, right? If it's greater than your max, then what are you going to do? You're simply going to assign your max to be equal to ARR of I. That's it. Equal to ARR of I. Okay. Now, once you're done with this, you're going to come out of this loop and you are going to basically print your output. So it will be system.out.println and you're going to just return your max. Okay. So if we go ahead and run this, oh, there is a compilation error. Oh, I'm sorry. I mentioned I, it should be 1. So, yep. Where do you see the answer? Okay, you see it here. Okay, it's too small. I don't know why, but if I zoom in, you can see it is 3, right? Yep, so that is it. And I highly recommend you taking this input as a user input. So maybe you have more clarity on understanding the question. Okay, just use the scanner class. That's it. Very simple question. Do not rush looking at the length of the question. Yeah, definitely. I agree. It's a little long, pretty long actually. But do not rush. It's simple, not complicated. So we'll go one by one. It says you are given an array. You're already given an array ARR, okay, which has n integers. You want to construct a new array called RES or the result using ARR by following this algorithm that is given. So it says initially RES is an empty array, correct? Because it's a new array, it says that this is empty. Start at any index of ARR. Now, ARR, suppose it has n equal to 5 and say the indexes are 1, 2, 3, 4, and 5. Okay, you can start at any index. Let's say we start here at index 1. Okay, so choose a direction whether you want to go left or you want to go right. Okay, and iterate over the elements of ARR starting from the chosen index in the chosen direction. So if I say that I want to start with index 1 and I want to go left, that is towards 1. So what will my answer look like? So this will look like something like this. Okay. So I started here and I went all the way over here. Okay. So what happened? Like add each iteration element to the end of RES. Okay. So sorry, this is not ARR. This is going to be RES. Additionally, it is given that your ARR is cyclic. So that is exactly what I did. I started over here 2, 2, 1, 1. Then what will come if it's a cycle? 5, 4, 3. Okay. So this is exactly what I meant by cyclic. Okay. Now, addition. Okay, this is done. This means after the last element, you can still iterate to the first. Okay. Fair enough. After this one, you can go back to this, and vice versa. From here, you can go back to there. Right. Now, the value of RES is the sum of the bitwise XOR operation. Okay, of all its prefixes. This means that RES can be stored like this. Okay. You can, what you have to print is the maximum possible value of RES. Okay. Now let's go down to the thing. Now there are two things. Okay. First is it's in cyclic order. So it can go in anti-clockwise direction. It can go in clockwise direction. Keep this in mind. Okay. Now it says n is equal to 10. ARR is this. Correct. So answer is this, considering that your RES after rotation is this. So that means this is your first. So this is your first. So this was 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Correct? So it started at index 2. So if you start at index 2 and it probably went in left direction because I see an 8. Because if it would have gone in the right direction, it would have been 5. So it will write 8, then 7. Then it will go to the end. So at the end, what is it? 6. So you see 7, 6. Then before 6, it's 1, 1. Then 0. Then 2, 2, 9, 5. Correct? So it basically went like this and then started over here and traveled all the way till this 5 again. Okay. But how are we calculating? It is basically the XOR of the previous, the sum. So you're starting with this, then you're going to do XOR between these two, then it will be these three. Correct? That is what the example is saying, right? Then you will do XOR between these four. Okay. And so on, it will continue till you do XOR of all these 10 elements. Okay. So they have already given the value as the answer. So this is 5, then this will be 13, 10, 12, 13, and so on. And when you add all of this, this will be 99. Okay. But if you look here, it says you have to return the maximum possible value. That means you have to return the max value. So you agree, right? If I chose a different index instead of 2, if I chose this 3, then my XOR operation will be different, right? So for all the indexes, whatever index I choose, that will determine my value for these answers, correct? So that is why what I have to do is to take max and return the max, whatever the value is max, okay? In this case, 99 will be the highest. So we are going to return this pattern. Not returning this pattern, we'll return 99, but we are going to compare all the values considering all the permutations. Okay, remember there will be two things, clockwise, anti-clockwise. All right, so let's see how we can actually code this. So suppose we have ARR which is equal to your we'll take the same one. Okay, 8 5 5, then I guess it was 9 2 2 0 1 6. Okay, once this is done, we are going to do n is equal to the length of ARR. Okay, now max value, we need to find this, right? So we'll assign it to be 0. We'll start a for loop. Okay, say start in your range n, correct? Because you have to iterate over each and every element. So now this will be a traversal in clockwise direction. So your RES is nothing but ARR of your start plus 1, whatever you have selected your start to be, okay, for everything. How do we calculate this? So we are still going to use the XOR operation, but we are going to do this first. And again, this another for loop within. Why? Because we have to iterate for every single element and find the combination in every single element, correct? So this will be in the range n again. Okay. You will set your answer to 0. This will keep track of whatever the answer is, and this will be your total, which will also be set to 0. Okay. Now you will iterate I in your result set res. Okay. And here you are going to do the XOR operation, XOR bitwise operation that you have. You're going to do it here on I. Correct. And your total will be what? Total plus the answer. Okay. This will be your total. Now we have to find the max value, right? So max value will be equal to your max of whatever the max value is, or if total is greater. Okay, you're going to do this. We are going to copy this whole thing because this was for the clockwise, right? Now for the anti-clockwise, okay, we won't copy the for. I'm sorry, I copied it wrong. Okay, so we'll copy this and we are going to write this part again. Okay, so this is going to be the same thing except that this will be minus. Okay, otherwise you are going to do everything same. So I'll just put it up here that this is your clockwise and this is your anti-clockwise. Okay, so this is the only difference that you will have, anti-clockwise or counterclockwise, whatever you call it. Okay, it's same, just clockwise will be addition, anti-clockwise will be minus. Okay, because you have to go backward. Now we will go out and just print. What are we going to print? Our max value. Okay, that's it, right? So it wasn't that complicated. I will just zoom out so you can see the whole thing, and let's run this. So you see it's 99, right? So I have hard coded this, but if you want, you can definitely take input. Like, I hope you guys know how to take an input. If not, you can refer back to the video where we have learned how to take input in Python, specifically from the point of view of an online assessment. All right. So I hope that you have understood this question. This is exactly how you will iter over, starting at your start, whatever your element is. Basically, you're going to do it for every single one and you're going to return the maximum. All right. I hope this video was helpful. I will see you in the next one. And until then, keep learning. And yes, for the time complexity, definitely what will be the time complexity? It will be big O of n. Okay, because we're just using one loop over here, right? And this can happen in a constant time, so don't worry about this. Okay. And your space complexity, I'm sorry, your space complexity will be equal to big O of, are we storing anything? We are just storing max value, and that too, that's a part of your return, so it should be a constant. Okay. So I hope that you have understood this. And so we are going to do the same question in Java as well. So it will start as usual with public class main, and feel free to use your own compiler or editor or whatever you are using, your own IDE. So, or you can use the online free one that I'm currently using. All right. So you're going to start with the same things, no difference in the start. That's the main class and your main function. And now we are going to basically assign an array, and that will be called as ARR, and we will hard code it here. But if you want, I would rather say, if you, I mean, you should technically have like a proper code written, like take a scanner class and take the user input. I'm sorry, I guess I missed something, and yep. Okay, so we are going to have the numbers here, 8 5. I'm sorry if I missed some number, but I guess this is the correct order. 2 2 0 1 and 6, correct? So once this is done, you are basically going to then take an input n, and it will be equal to your length of the array, right? So we're going to take the length, and then you're going to have something called as int max value. Okay, or just let's keep it val, and we'll keep that set that to 0. Now we are going to run this for loop. Now, what is this for loop going to run from? So it will have your start index. So it will start at 0, and then your start will be less than the length, right? Length of the array, that is n. Now, once this is done, what will you do? You will simply increment your start, correct? Now, this is for what are we going to write now is the clockwise direction. Okay, so for clockwise, you're going to do this, that your result is equal to a new int. We are creating a new array where our result will be stored for the clockwise. Okay, then you will have your for, and you are running this loop again. I is equal to 0, I less than n, and I plus plus. Okay, so once this is done, we are then going to append the value to the result set that we just created. We'll put as result of I is equal to your ARR of, it's going to be the start plus 1, actually star plus I, and we are going to take the mod value of n, right? That is what we'll be doing for the for. Now, once this is done, what are you going to change this to? You are going to basically do another variable, that is answer, which will have 0. And then you're going to write down the total, which will also be assigned to 0. Now, once this is done, you're going to run a for loop. Now, for loop will run for what will be the thing? It will basically run for this. And what are you going to basically do? You're going to take the XOR value of your answer along with the value. Okay, if both of them are existing, you have to do that, and your total is equal to your total plus answer. Correct? That is all that you have to do. Now, once this is done, you're going to return the max val. You're returning the max val, which is equal to the which is equal to the math dot max, and max of what? Either the max value or your total, whatever is greater. Okay. Now, this was for clockwise, right? For counterclockwise or for anti-clockwise, what will you do? So for I again, so it will be assigned to 0, and again I less than n, and I plus plus, right? So once this is done, you're going to run this loop again. So what are you going to do? Basically, I'm going to copy this formula from here. So it's going to be the same thing, but we are just going to tweak a little bit here. It will become minus, and it will also have plus n, right? That was the formula. So once this is done, you are here, and you're going to go down, and you're going to again reset your answer to 0 and your total to 0. Once this is done, you're going to again run the same for loop. Okay, for int of value to the result. Now, once this is done, you're going to calculate the answer, that is the XOR of answer and the value. And then you will do a total, which is going to be equal to, which is going to be equal to total plus your answer, right? Once this is done, again, what do you need to do? You need to find the max value. So I'm going to copy this. Okay. So it's the same thing. And then once you exit this, you are going to simply print system dot out dot println return max value. All right, that's it. So we are going to go ahead and run this code. I don't know if you can see the answer. Yeah, so there it is, 99, right? So the output of this question was 99. Why? Because that is what we have assumed, this array. So again, I want you to take this array as an user input. So try using the scanner class and try solving this, right? So these questions are actually asked previously. So yeah, you can look into the type and the kind of question they are asking, mostly related to arrays. So this is also kind of the same thing. So you have an array and you need to perform the given two tasks. Okay. First, if the array length is greater than 1, then take any two numbers where x is not equal to y and remove x and y. Okay. Else take x and remove x. Okay. So simple. And what you need to do is to count the minimum number of steps to remove all of the element. Okay, you don't have to uh, do anything else. How do we go about this? So now this one, first let's understand this. This is your x, this is your y. X not equal to y is true, so we are going to remove both of these at the same time, right? So that is why in how many turns we can remove it? 1. So that is why your output is 1. Now here your x and y both are 2, right? So this is a false condition, so you will just take x and you will remove it first. This will be 1. Then you will take this x and remove it again. So it will be another 1. So 1 plus 1 will be 2. That is why it is 2. Okay. Similarly, over here, if we consider this, you have 2, 2, 3, 3, and 1. Okay. Now, when you have more than two options, this is fine. How will you, if it's more than 2, how will you take your x and y? We'll consider x here and y here. Okay. So we'll see x not equal to y. In this case, 2 not equal to 1 is true. So you're going to get rid of this. You're going to get rid of this. Now your x is this and this. Okay. Again, 2 not equal to 3. This is also true. So you will get rid of this and you'll get rid of this. Then you're just left with 3. That is just x. You get rid of this. Okay. Because in all the step, you're just removing it, right? So how many times did you remove? 1 time, 2 times, and 3 times, right? So your output is 3. Got it? I'm sorry, I wrote this by mistake. It should be like this. Okay. So basically, what we are aiming to do is we need to sort it. So suppose we are given values like this. What will we do? The first step will be, let's sort this. Now, once we sort this, what do we have? We have 1, 1, 2, 3, 5. Now we'll consider this and this. These are not equal, so they'll get eliminated. Now you're left with this, correct? Now this and this are not same, so these two will get eliminated. Now you're left with this. This is just a single letter, so this will also get eliminated. So how many steps? Step 1, 2, and 3. So what will be the output of this? Output will be 3. Okay. The question might seem difficult, but it's pretty simple to execute. Okay. Let's try coding this one. So let's take an user input, say int input. Okay. And say let's have ARR is equal to, we'll have how we take input for your array. So it will be list map and it's an integer type. So int, we'll take input, but we are going to split it from the space. Okay. Because if you look into the example over here, they are separated by space. So we should assume while taking user input that it will be separated by space. Okay. Now we'll take our answer and assign it to 0. First, we'll do ARR dot sort. Okay, we'll use the sort algorithm because in the question, it nowhere says that you have to implement the sort yourself, right? Then we'll do while your length of ARR, okay, is not equal to 0. Till that time, we are going to run this loop. And what will we compare? We'll compare if your ARR of 0, if your ARR of 0 is not equal to your ARR of -1. Okay, the last element from the reverse direction. Okay, because if we do the consecutive, it might be that we have some duplicates in that or something. So we are going to consider it to be the last element. Okay, the first and the last element. Okay. And moreover, this is mentioned in the question in the example. Okay. So yeah, right here you can see it's the first element, last element. First, last. Sorry for the explanation here, though I just miswrote this. But yeah, this is the first and the last element. Okay. So that is why you're going to do this. What will you do if it is not equal? You will do pop, a dot pop. Okay. And it's not a dot pop. Sorry. We have ARR dot pop. And then we'll do ARR dot pop 0. Okay. So this will remove your last element. Okay. And this will remove your first element. Okay. Now the else part will be when it is equal, right? This was not equal. Now this is equal. Now if it is equal, you're going to pop 0. Now why did I not write -1 over here? That is because in stack we basically use LIFO, right? The last 10 will come out first. So if you don't even mention the index, it is still going to pop the last element that is entered. Okay. And that is exactly what we are trying to do. We are going to move the last element and the first element. So moving the last element is simple. Just do pop. In order to pop the first element, you need to specify the index. Got it? But here, when it's the else, when it's not true that your x is equal to y, in that case, you're just going to pop the first element. Okay. That is the x. Now, once this is done, you're going to increment your answer by 1. Okay. And finally, just print your answer. Okay. And let's run this. So suppose I'll enter, say, 2. Let's do it for whatever options we have. 1 space 2. Okay. So it will be 1. Now let's do it for the bigger solution that we had. It was, I guess it was 5 spaces. So we'll do 2, 2, then 3, 3 and 1. And if you run this, it will be 3. Okay, just how we saw here in the explanation that it was 3. Okay, here 3. And if you just try this, we'll still get the same thing. So let's run this and try it. So it was 5. Then we had 5, 3, 1, 1, and 2. Okay, that is also 3. Got it? So talking about the time complexity. Now what will be your time complexity? It will be n of log n. Why n of log n? Because this sorting itself will take log n, right? And then you're going to run this loop for n times, right? You're going to run this loop for n times because you have n elements, okay? So that is why it will be n log n. And okay. And what will be your space complexity? Your space complexity will be equal to a constant. Why? Because you are actually not storing anything, or maybe you can consider that you are storing. So this is again debatable whenever it comes to space complexity. It's up to you what you choose, because honestly speaking, this sort is part of your thing and you are returning that same ARR, right? You are just doing it in place. So anyways, but that is completely up to you if you want to consider. And we'll see if what goes fine with it, and according to the scenario you can choose. You can say big O of n doesn't matter, you can say big O of 1 doesn't matter, okay? Or because we are actually not storing anything, but yeah, we are doing sorting, so kind of way we are going to use some space. All right. I hope that this video helps and you have got clarity on how you can solve this question. Not difficult. You can try hard coding this, or you can try any other way that you know. Okay, I think stacks is the best way you can solve this question. Even though they took an input as an array, I think you can definitely convert it into stacks and solve it. So if you remember from data structure, stacks in Python, it's actually implemented as an array. So yeah, you can use it, right? So we are going to solve this same thing in Java. So we already have the initial base structure. So let's take a user input. So we'll take the scanner class, which is equal to your new scanner system.in. Okay. And what are we going to take in as? We'll take the n, like the number of monsters we want to have. So that will be not the monsters I'm talking about. I'm sorry. We'll take in the number of elements that we want to enter, the number of numbers that we are entering. So we'll do it as this, and then we'll have the list of integer. Okay, and let's call that maybe a. Okay, and then we'll have the new array list. So that will be empty, and we're going to do this. Okay, so this is exactly how you create an array list in Java. So for int I is equal to 0, what are you going to do? You're going to run I till less than n and I plus plus, correct? Now once this is done, it's going to do a dot add, because it's an array list. So you're going to just do the scanner dot next int, whatever value you have in here. Okay, so once this is done, you're out of this loop, and then you're going to initialize your answers to say 0, and we'll use the sort. So we'll take collections dot sort and use a. And once this is done, now we are running the actual while loop, that is till your a is not empty. So we're going to just check not is empty. Okay, so till that time we are going to run this loop. And what will your loop have? So it's basically going to check if a, I mean not of a dot get of 0 is equal to. Okay, so how do you write equal to? So just write equals. And again, what are you going to do? A dot get what? Need a dot size. Okay, minus 1. Why? Because you're starting at 0. Okay, so 1 2 3 bracket, perfect. And then what are you going to do? You're basically going to do a dot remove a dot size minus 1. Okay, now this is to remove the last element. Now to remove the first element, what will you do? You will again run an if. Now how will you run this if? It will be a dot is empty. Okay, just that much. And if you run this, you're just going to do a dot remove what? 0, not minus 1 but 0. Just the index 0, because this is the first element, correct? Now once this is done, you are here. What are you going to basically do after you are here? So you are going to run another else part. What will this else have? Now else will be to like both ends are equal, so remove one and increment your answer. Okay, so you will just do a dot remove. What will you remove? 0, because both ends are equal. Okay, and finally you need to just increment your answer. Okay, that's it, and finally you are out of this entire while. So you're just going to do a system dot out dot println, and what will you print? Your answer, right? We do the answer. So that is it. Let's run this. Did I miss it somewhere? While initializing, right here. Okay, my bad. So yeah, let's run this. Okay, now let's say we'll enter 1 and 2. So should return 1. Okay, I'll just expand this so you can see. So it returned 1, right? You can try adding the previous numbers that we have used for the Python code as well and see how it goes. Should work fine, but this is the code. Okay, even though it's pretty lengthy question, you can see it's simple once you understand this. It's just a story based to drag you here and there. Okay, so it says that you're playing an RPG game. You were assigned to complete one of the hardest quests in this game. There are n monsters, okay, and you will need to defeat them in this quest. Each monster I is described with two integer numbers, power I and bonus I. To defeat this monster, you will need at least power I experience points, okay? And if you're trying this monster without having enough points, you will lose immediately. You will also gain bonus I experience points if you defeat this monster. You can defeat the monster in any order, that doesn't matter. The quest turned out to be very hard. You try to defeat the monster but keep losing repeatedly. Your friend told you that this quest is impossible to complete. Knowing that, you are interested in what maximum possible number of monsters can you defeat. Okay. Now, how is the input? Input is in few steps. Okay. The first line is denoting n, that is the number of monsters. Okay, then the next line is integer e, denoting your initial experience. Now this is your experience points. Okay, next it contains the integer power I, which represents the corresponding power of the monsters. So these two are basically power I. Okay, this is for monster 1, this is for monster 2. Okay, and last line is the bonus I. So these two are the bonus I. For this is for monster 1, this is for monster 2. Okay. Now what is your initial experience point? That you have 123. Now one monster has 78 power I and bonus I is 10. Other one has power I as 130 and there is no bonus for this one. Okay. How many monsters can you defeat? So what will it do? You need to have at least an experience of this much to defeat this monster, right? So if you check, you can only defeat 78. You cannot defeat the monster with 130 because you have pretty less. Okay. So you are going to defeat this one first. Once you're defeating this, this monster's bonus I will get added to your experience point. You will have 133. Correct? Now, you have 133. Can you defeat this? Yes, you can. Okay. So you don't have to add anything because this is 0. Correct? So how many monsters did you defeat? Defeated one, you defeated the other one. So you defeated two. So that is why your output is 2. Alright. So how do we go about this? So now that we know that we are given n number of monsters, we are first going to sort it. Okay, so once we sort it, we'll have it in order. Correct? Now in order, when we have it, it will be easy for us to just traverse over each of them and see if this number is less than my initial experience or just the experience points or not. If it is less, then we are going to then we are just going to go and kill that, else we will not. And once we kill that, we are going to add this bonus point to the initial experience point. Okay, so how do we code this? So n is basically your number of monsters, right? So we're going to take that input. So I'm going to do this for you as an user input so you actually know how you can write it. Now, this is say initial experience EXP, and we will assign that as well to as input like this. Okay. Then we have power. So we'll take that as P, and this will be a list of numbers, correct? So it will be input. And for how long? It will be for in the range of your n, correct? And we are going to copy this because this is going to basically be the same for your bonus I as well. Okay, so that is going to be the same thing. Now, once this is done, what are you going to do? You're going to basically take a variable a and you're going to sort these. How will you sort it? You're just going to use the zip thing and you will sort in the order P and B. Okay, so basically, this is creating a map for you. For every P, there will be a B value, and then you will have your answer set that will be assigned to 0. Now, for power and your bonus in A, okay, you're going to compare if your power is greater than your EXP. If it's greater than your experience, then just break out of that loop. You don't want to do anything. Okay, and then what will you do? You will just increment your experience by your bonus. Okay, else you're just going to do that, and your answer is basically the counter that is keeping track of your number of enemies or monsters that you have killed so far. You will finally just print your answer. Okay, that's all that you need to do. Okay, so we are going to just run this. So we'll have 2, and our experience was 123. And what was the value? I guess it was 78. Then it was 130, I guess. Then 10, then 0. All right. So your output is 2. So we have the basic Java code written here, and now we are going to actually code it. So we'll use the scanner class to take an input. So we'll do the new scanner system.in. Okay. And we are going to now take the input of monster, that is the number of monsters that you want. Okay. Dot next int. Now for the experience level, I will use say the variable lev level. Okay. So we take that also as an integer input. So same like this. And then what are you going to take input as? The power I and the bonus I, right? So you're just going to say P is equal to new int, maybe just n, right? And similarly, your this will be B equal to new int, you will pass n, right? Now for your int of I is equal to 0, you're going to do I less than n and I plus plus. Now, what are you going to do? Basically, you are going to consider the power i's and you are going to just iterate over them and see what you have got for all the respective monsters that you have, correct? Now, once this is done, you are going to basically run another for loop. Now, for what will you run this? You will run these for the bonus I, okay? So it's going to run for int I equal to 0, for I less than n, I plus plus, correct? So B of I will basically be again your scanner class. You're just calling it to just take the respective values for the monsters that you have, right? So this is all the input that you need. Now here begins your actual code. That will be a list of what? It will be a list of integers basically, right? And that will be equal to new array list. Okay. Now once you have created this, what are you going to do? You'll run the loop again. That is int of I is equal to 0, I less than n, and I plus plus. Okay. Now once this is ready, you're just going to add the elements into the array or the array list that you have just created. And what elements will you be adding? You will be adding the power I and the bonus I, right? So you have this, this, and this. Perfect. Okay. Now, once you're out of this loop, What are you supposed to do? You're supposed to sort it, right? It should be in a sorted order. So I'm just going to use a thing called as comparator. If you want to really write it in a different way, you can do it. I am not going to stop you from doing that, but this is a direct function that I'm just going to use it here, okay? So this is going to do this, and int answer is equal to 0. So what will you do? Your next step? Your next step will basically be to run the for loop. Now, for what will you run this for loop? You will run it for every pair, right? You need to compare the pair that you have. So where is the pair stored? It is stored in A, the sorted one. Okay. Now, int of power is equal to pair of 0, and the bonus is pair of 1, right? So pair 1. Okay. Now, you're going to just compare if your power is greater than your level or your experience. Then what are you just going to do? You're going to break, because you cannot fight that monster. That is not possible. Okay. Next, what will you do? You will just increment your level with bonus. Otherwise, you're just going to increase your experience with the bonus, right? You can kill it, and your answer should be just incremented by 1, right? So that is all. And once you are out of this, you're just going to print or return your answer. Print ln, and you will return your answer. Okay, that is all. So let's run this, and I will increase this. So yeah, so say we have two monsters. My level is 123, then I have 78, then I have 130. These are my powers. Now I have my bonus as 10 for the first monster, and for the next monster it's 0. So you have 2. You could successfully kill both the monsters. All right. So this isn't difficult. Don't get scared by the length of the question. We often give up when we see it being this big. Pretty simple question. It's saying that one of the first lessons IT student learn is the representation of natural numbers in binary, right? That is base 2. This system only uses two digits, 1 and 0, or 0 and 1. In everyday life, we use for convenience the decimal system, that is base 10, which uses 10 digits from 0 to 9. In general, we could use any numbering system. Computer scientists often use the system based on 8 or 16. The numbering system based on K uses k digit of value starting with 0 to k minus 1. Okay, so if it is 8 base 8, that means 0 to 7. If it's base 10, then 0 to 9. Okay, like that. Suppose natural number m is written or given and written in decimal system, that is in 10. Okay, you have to convert it to the corresponding system based on k. We successfully divide m by k until we reach a quotient that is less than k. Okay. So the representation of m in the system K is formed by the final quotient. Now, how is this basically happening? So, for example, your m is 122, and this is in decimal, right? That is what is mentioned. Your K is 8. That means you have to convert 122 base 10 to 122 in base 8. What is 122 base 10 when converted to base 8? That is 172. And how do you get that? So, basically, you divide it by 8. So, you have 2s are get guess, so this will be 15, and then you will again divide this with 8, so your this will be 7, remainder will be 7. These are remainders, okay, and these are the quotient. So, and finally when you divide, you will just have 1 as the quotient. Your quotient is now less than 8, so you're going to write it in this direction, so it will be 172. Okay, so that is exactly how you have successfully converted 122 base 10 is equal to 172 in base 8. These two are same. Okay, this is the exact definition or example that it is doing. Okay, now you have made the following observation in applying the above rule of converting natural numbers to another numbering system. In some cases, in new representation, all the digits of the number are same. For example, 63 base 10 is 333 in base 4. Okay, now what is your question is here. What you need to do is here, given a number m in decimal representation, so your m is given in base 10, your task is to find the minimum base 11 base b such that the representation of m at b, all the digits are same. So basically you are going to do this. Okay, you need to find a base where all the digit will be same. Okay, now how's your input? Your first line is denoting m, that is the integer number that is given in base 10. So for example, this is in decimal 41 base 10. Now here 41 in base 40 will be 11. Okay, so if you do 41 base 40, the output will be 11. Okay, so both the numbers are same. In which base? In base 40. So what are you returning? You're returning base, the base, that is 40. Okay, all right. So in base 40, digits allowed are from 0 to 39. Representation 11 is within that range. Okay, so how do we actually solve this? So basically what you're doing, you're taking an base m, you're finding that same number in a base b such that the resultant all the numbers are same. Suppose xx or xxxx or whatever, they are all same. Okay, so how will you do this? This has a very simple approach. Okay, now I am going to write this in a little sophisticated way. You don't have to do that. Suppose I say that m is your integer, right? So I will do int input. Okay, if you want, you can actually write enter m whatever you want, okay, within the quotes, but I won't be doing that. We will consider your min base to be 2. It's already given in the question that your min base, it cannot be 1. Okay, no base 1, base 2 and more. Okay, so we'll set your up min base as 2. Once we do that, we are going to define a function, say all digits same. Okay, we are going to call this as all digits same. We'll pass m and we are passing b, that is the base. Now, you will create an empty list of digits because you have to eventually return that only. Okay. So now what are you doing? You're going to take a temporary variable and assign that to m. Okay. Because m has been defined outside the function. So we're going to take a temporary variable and define it as m. We're going to check if temp is greater than 0. Fair enough. If your temp is actually greater than 0, which it should be, then what will you do? You will do digits dot append. You're going to take temp mod of that base. Okay, why mod? Because we are going to consider the, how do we actually do the division thing, right? We need the remainders. We are actually accumulating the remainders, correct? That 1, 7 and 2, if you remember, I told you right here, these are the remainders. Okay, the 1 is the quotient, but others are the remainders. Okay, so we are going to take the mod to find them, and then what will we do? We'll do an integer division by b. Okay, so you're going to be, temp is going to be equal to an integer division of temp by b. And finally, once we are done with the looping, we are going to return the length of set digits. Okay, and we have to make sure that all the digits are same. Okay, if the set has only one element, correct? Because set will avoid your duplicates, right? So if you're using set, that means it is only going to return those numbers where it will figure out that okay, it is 1 1, it is 2 2, it is 2 2 2, it is 3 3 3. Okay, so it's going to compare. Now, if it is 3 3 3, now this is an array. So it, if you put that up in set, it is just going to have one digit, that is 3. But if it was 32, then the set will have two digits, 3 and 2. Okay, because they won't be same, right? So once you're done with that, we are going to run a loop for b. So in the range, it will be min base m, and you're going to compare if all digits same m comma b. Okay, if this is true, then you're simply going to print b, else you will break. Okay, so if we run this and we just have to enter, the number was 41 that was given to us, and you see it's returning the output 40. All right, so I hope that you have understood this question wasn't difficult, and I mean, if you get the catch of what you're exactly doing, and how it has to be done. So I guess this return statement is tricky here. If you don't capture that, or you can use set, so it will have a single number if they are all equal because the digit is in an array form. So I guess that's the capture. If you get that, the rest of the code is simple. Okay, so we are going to do the same thing for Java as well. So we'll start by writing the Boolean function to figure out that all digits are same. So we are going to do static Boolean all digit, all digits same. Okay, and what are we going to pass? We're going to pass int m and we'll pass the base, correct? Now, once this is done, we are going to use the set. And to use set, this is exactly the syntax of set. I hope you guys are aware of it. Is equal to your new hash set. Okay, this is exactly how you write it. Now, what are you going to do? You're basically going to do int. We'll take a variable, say temp, and we'll assign that to your m, whatever your number will be. Okay. Now, while your temp is greater than 0. Okay. Now, what are you doing if that's the case? You're doing digits dot add. You are calculating the remainder, right? We saw in the dry run. So it's the remainder. And then you're going to do the division of temp by b. Okay. Or by the base, whatever you want to call it. Once this is done, you're going to return digits. Have I taken digits? Yes, I've taken digits dot size and equal to 1. Okay. And so what will it do? It will only return the ones that are unique. Okay. So once this is done, now you are going to write the main function from where the function, the code will start. That is public static void main and the normal thing, the string arguments. Now, once you're done with this, we'll take a user input. Okay. And this is exactly how we take an user input in Java. We'll do int m is equal to your scanner dot next int. Okay. And we are going to assign our min base as well. What will be our min base? Our min base will be 2, correct? The minimum base that we are going to use. Now we are going to run a loop. We are going, we are going to run a loop and it will run from int b should be equal to your min base. Okay, should at least be 2 and your b should be less than m, right? That's the condition that's given in the question. And what are we going to do? We are simply going to do b plus plus. For that time, this loop will run and we'll check what? That if all digits same, if this is true, then what are you going to do? You're just going to print that. Okay. I am just going to write a small statement. Please avoid writing any kind of statement in the exam. You're just going to return it. Okay. So here I'm just writing so that we can just differentiate. Suppose I want to write, say, minimum base. Okay. And put a colon plus b. Right. You guys are not going to write this minimum base thing. You will just return b. Okay. Or just print b. And then once this is done, just break out of the loop. Okay. So one more thing that I would insist you people to do if you want to, that is se dot close. Make sure you just close the scanner class that you had opened. Okay. So now if we run this, I'm going to increase this. So let's enter 41 and the base is 40, right? So you're not going to write this statement. Just avoid writing this statement. Just print B. Okay. This is pretty interesting because it's a lead code medium level question and a FANG favorite question that has been asked by Google, Microsoft, Amazon, Bloomberg, Walmart, everyone, right? And even by Infosys. So it says basically that given a triangle array, your work is basically to find the minimum path that is from the top to the bottom. Okay. That's all that you need to do. Okay. What you need to do is you need to find the value from the top to the bottom. Now it says it has to be such that each step that you move, it should be to an adjacent number of the row below. That means either you can move to index I of the next one or I plus 1. That means we'll understand this better. So if you see, this is a triangle that is given to you. And the output is 11. Why? If you consider this, you see it's 2 plus 3 plus 5 plus 1. Now you must be thinking, oh, it is the minimum of every element in the given row, right? But that's not the case. This is where the understanding of why it specifically mentioned index I or I plus 1 comes into picture. Okay, so if you apply this from top to bottom, you will get an error. This should go from bottom to top. This is dynamic programming. Okay, and how do you get about this? How do you solve this? We will see this in a moment. Okay, so suppose you have this. Okay, now that you have this, it says that, okay, give me a moment till I get rid of these marks. Okay, so you have 2, you have 3, you have 4, you have 6, you have 5, you have 7, you have 4, 1, 8, 3. So instead of coming top to down, we'll go bottom to up. How? It mentioned two things, I and I plus 1, right? So we'll start at the second last level. Okay, if we consider the value of 6, right? Now 6 has two elements, that is 4 and 1, correct? Now if suppose this is the only tree that you have, okay, so this is the 0th index, that means you can either go to 0th index in the next row or 0 plus 1, that will be the 1 index 1, right? So in the next row this is 0 and this is 1, so technically 6 can access these two. So what will you do? You will make a sum of this plus this. Then you will do a sum of this plus this. And then you will compare which value is less. Whichever value is less, you're going to replace 6 with that number. So if I do first, I'll do 6 plus 4. Next, I will do 6 plus 1. This will be 10. This will be 7. Which is smaller? 7, right? So you are going to get rid of this 6 and you'll replace it with 7. Okay. Similarly, we'll do it for this number, that is 5. So 5 will have two things, 1 and 8, right? Now 1 and 8. So 5 plus 1, 5 plus 8. So 5 plus 1 is 6. This is 13. So which is smaller? 6 is smaller. So you're going to replace 5 with 6. Okay. Similarly, let's remove all of these. Okay, similarly, you have one more element in that row, that is 7. So what will you do? You will be basically adding 7, either 8 or 3. So it will be 7 plus 8, 7 plus 3. So 7 plus 8 is 15, 7 plus 3 is 10. So you will replace 7 with the smaller one, that will be 10. Correct? Now we are done with this as well. So we'll go to the above level, right? To the level 2 right here. So now your 3 has two things. One is 7, the other one is 6. Correct? Now you will do 3 plus 7, 3 plus 6, which will be 10, and 9, which is small. 9 is small, so you are going to replace 3 with 9. Okay? Now one more you are left with, and that is 4. So 4 will have 6, 4 will have 10. So you will either do 4 plus 6 or you'll do 4 plus 10. So this will be 10, this will be 14. 10 is smaller, so you will replace this with 10. Right? Now this is done, so you're going to move to the topmost level now. Okay, the final level. That will be your 2 either goes with 9 or goes with 10. So you will do 2 plus 9 or you will do 2 plus 10. So this will be 11. This will be 12, which is smaller. Definitely 11. So you're going to replace this with 11. And this is your minimum. And you're going to return the minimum sum, that is 11. Okay. This is exactly how you're going to implement. And this is a DP in bottom up approach. Okay, so if you haven't really seen the data structure course, I would recommend and just go and check out what is the dynamic programming. Four most important things that we do in dynamic programming. First, the normal brute force, then top down approach, which has recursion. Bottom up has no recursion, and that is why it's more preferred. And if there's a chance, we must try optimizing the bottom up as well. In this case, we don't need it to, because this is the optimized version. So yeah, this is exactly how you can solve easily. So this index was not given for top down, it was rather given for bottom up approach, right? So how do we code this question? So it's not that difficult. Exactly what we did is we just did the sum of these values that was just below the given index, starting with the second last index. So we'll start with the length of our triangle. Okay, we'll first figure the length of the triangle. Then we'll do a for I in range. Now this is interesting. So this should start from where? N minus 2. Again, it should not be the last line but the second last. That is why n minus 2 and then minus 1. Minus 1. Why? Because we are considering the second last row. Okay, not the last row, second last. Now we'll take a variable m. We calculate the length of m as in the triangle at I. Okay. Now, whatever the length will be, for that we are going to run a loop. Now, this is a nested loop. Okay. So, for this in range of m, okay, I'm sorry, something's wrong with my keyboard here. So, yeah, well, once we do this, we are going to start with our left. So, what will be our left? So, our left is basically the triangle at I plus 1 and j, right? This is your left. And what is your right? Right is basically both plus 1. That means triangle at I plus 1 and triangle at j plus 1. Okay, so this is the index that we are going to use, right? Now, once this is done, you're going to check for the triangle again. So, triangle of I, j will be equal to your, sorry, so this will basically be the addition of your, the min one, comma, your right. Okay, left and right, whatever the minimum is. Okay, once that is done, you're going to exit all the loops and you will just return. What will you return? You'll return your triangle at index 0, right? Why? Because the topmost is the 0th one, right? So 0 comma 0, level 0, index 0. Okay, so we'll go ahead and run this and let's see. Yep, so this is accepted and it was as simple as that. We go ahead and submit this code and see if that works. Yep, that works and it's pretty good, not that bad, right? So if you definitely think there is a more improvised version, I would really love it if you can do it in a much better way. But this is one of the way that you can approach it. All right. So if we try solving this question in Java in lead code, what will we do? We'll take int n that will be equal to your triangle dot size. We are going to figure out what's the size. And now we are going to start from the second last row and we'll move upward, right? That is the trick over here. So we'll do for int of I equal to n minus 2 and I greater than equal to 0, I minus minus. Okay, so it's basically going to go in a decrementing order. We are going to run another loop for int j, which will start at 0 and it should be less than what? It should be less than the triangle dot get of both the indexes, right? Get of I plus 1 and what will be the other one? Okay, I'm sorry. So we are running this in j, so it should be triangle of get of I dot the size. Okay, we first need to figure out the size and then we'll do j plus plus. Okay, now within this we are going to actually do the left and the right side. So here you will have your I plus 1, right? So we'll take the variable say left, which is equal to triangle dot get I plus 1 and dot get j, right? And just the reverse, not the reverse, I would say same, but j plus 1 will be for your right. So right is equal to triangle dot get I plus 1 also dot get j plus 1. Okay, now once you have both of these, so suppose we name it as updated. What are you going to update? Basically you are going to basically update the value of the new node, right? So what are you going to do? You're going to do triangle dot get I and get j. Okay, along with what will it be? It will be the minimum of both of them, right? So you'll do math dot min left or right, whatever is the minimum value, that will be updated. Okay. And so finally, what will you do? You will do triangle dot get I. Then you're going to just set your j to be it to be the j or the updated, like it should be the set of that. Okay. Once this is done, you're coming out of both the loops, and finally what will you return? You will return the triangle of both at the index 0 comma 0, where I will also be 0, j will also be 0. Why? Because the topmost element will be your smallest value, right? So you're going to return this. So we go ahead and run. So yeah, that is accepted. We can go ahead and submit this code just to see in case it's working or not. Yep, not bad. But if you have a better code, definitely go for it. I'm pretty sure people have written much better code than this. So yeah, you can just give it a try. Okay. So this is pretty simple because it is simple. Okay. So it says that you're given an array of t length. Each index contains two binary strings. Your task is to return their maximum sum, also a binary. That means whatever their maximum sum will be, you're going to return it in binary. Okay. First line contains the t array length. The next n line will contain two strings which shows binary space separated values. Okay, like m and n, they will be space separated. Find the sum of m and n in binary and print the maximum binary sum from the array elements. So it's not complicated. So this is the number of uh, length. Okay, like number of lines that you will enter. So in this case, you're going to enter 3 lines. Now by lines I mean line 1, line 2, and line 3. Okay, each line has value m and n and they are separated by space. Okay, so this is m, this is n. You have three of those. So the first one is 101. The next one is 100 for line number 1. For line number 2, m is this, n is this. For line number 3, m is this and n is this. Okay, so first step will be to convert each of them in their respective decimal form. These are given in binary. Okay, you have to convert it in, this is given in binary. You have to convert it in given decimal. If you convert this to decimal, your m and n, 101 is in decimal 5. This is 4. This is 6. This is 2. This is 8. And this is 3, right? So 1000 is basically 8. And 11 is 3. 110 is 6. 10 is 2. 101 is 5. And 100 is 4, right? We know this. Now, once we have this chart of m and n in decimal, right, we are going to add another extra thing, that is to find the sum. 6 and 2, and the last one is 8 and 3. Okay, so we are going to find the sum. So what is the sum of these two? This plus this is 9. This plus this is 8. This plus this is 11. Now which is the maximum? 11 is the maximum. So you're going to find max of the sum, which will return 11, right? Now you're going to convert this 11 back to binary, that is base 2, and you will return the value, that is this, in binary. So you see your output here. Your output is given as 11, that is in binary. Okay, got it? So this is not complicated. It is simple. So we will go here and start coding. Yeah, it is complicated in a way that few steps are included. So since it says that t is the value that you need to take, so we'll go ahead with t and we do input. Okay. Now, once you are done with this t thing, we will take an array called answers that will basically store the list of everything that we'll have. Okay. At the end, I will print everything and show you how things are working out. Okay. So we are going to run for, say, I in range. What will be the range? It will be t. Okay. It's not n over here because it has been specified in the question. Now we are going to take two numbers, m, or maybe just go with small m and n. Okay. Which will be equal to your input dot split, will split from the space. Okay, because it's written there. Now your m is given in which format? Your m is given in, we'll assign this to another variable. So your m is given in base 2, it's given in binary format, right? So m comma 2. And similarly your n is given in, again, base 2, that is binary of 2. Okay, so it will be 2. All right. Now, once you have done this, I'm going to take a temp value that will store the sum of these two, that is m plus n. You can just make this look nice. Okay, once this is done, you're going to just append your values of m to your answer. The temp value will go to this. Okay, not m, sorry, temp. Okay, once you're done with this, you exit the loop and let's print few things. We'll first print the answer, then we will print our max of the sum, okay, or the answer. So yeah, because that's going to figure out what the maximum is, right, out of all the 3 or 4 sums that we'll take in. Then we'll have print, and we are going to convert this into binary of max answer. Okay, so let's run this. We'll enter 3, and what were the values? It was 101 space 100, then 110 space 10, I guess, and then it was 1000 space 11. Okay, so you see, so your answer that was stored, this all the sum, it was this, right? If you go back to the question, it was 9, 8 and 11, and that is what you've got, 9, 8 and 11. What is the max of 9, 8 and 11? It is 11, and we need the binary, so it is returning in binary. 0b basically means it's binary. If you had x, it would have hex, it would have had x. Okay, now one thing, how do we change this B O 0B to just this, because our output is in this format, just 1011, right? It's just the numbers. We don't have this 0B over here. How can we change that? So I will take another variable, say final equal to, and I will put it up as bin max answer over here. Okay, and once we have done that, I am going to change my print statement. I'm going to say final, and what value will we take? We'll take it from the second index. So this, if you see, this will be your 0th index, first index, from second index all the way till the end. So I'm not going to write anything after colon. I'm going to just do this. And now let's run this again. So 3. And what was the value again? It was 101 space 100. Then we had 110 space 10. And finally 1000 space 11. Okay, so now do you see it is printing this? You don't have to print these two. These two were just to show you it's running. Okay, so we'll just hash these out, and this is your final code. Okay, so if you want, we can run this once again, and we'll do this as 101 space 100, 110 space 10, and 1000 space 11. Okay, so you just have your answer over here. All right. So I hope you have understood this question. It was a pretty simple, easy question, not that complicated. So we have the outer structure in Java. We are going to take a user input using the scanner class. So sorry, it will be new scanner system.in. Now once you have this, you're just going to take int t is equal to, so this is the number of test cases that you want to take, the number of pairs that you want to take basically, equal to se dot next int. You're going to create a list now. This list is basically going to store your pairs that you will take it as an integer input, like the binary pairs. I'm talking about those. Suppose we call this ANS, or rather, I can say that we'll take this as an answer, okay, and we'll store our values here. So suppose we have array list, and we are going to append it to this only, and let's call this, and so we'll run this for loop of I equal to 0. I'm sorry, it should be int I equal to 0, then I should run less than whatever your t is, and I plus plus. So once you have this, you'll have two strings. Say string A is equal to your next, and your string B, that will also be equal to your se dot next. Right? So your first and your second binary has been taken as input. Now you will take, say, small a, and you are going to parse these two binary forms that you have taken as an integer, or rather you have to convert it into decimal. So you will do it as parse int, and you will say that this is in binary format. A comma 2 represents that. Similarly, you will take b, and you are going to parse that again. So you will say it is b comma 2 because it's in binary, right? Now, once this is done, we'll consider in temp to be a value where we are just adding this decimal form of A and B. And what will we do? We'll add this temp to the answer. Okay, we are just going to append it, right? Now, once this is done, you have to print the like let's just print and see the list of the elements that we have. So we'll do print ln and we are going to pass the answer. Now we have to print something called as the maximum, right? So we'll take a value, say int max val, which will be equal to, I'm going to use the collection class to just give me the max. Okay, and we are going to pass our answers list that we have, and we'll do a system.out.println on that. And what are we going to print? We are going to print the max val. Okay, now once this is done, what do you want to do? You basically want to print the binary form of this max val, right? This max val is in your decimal form. So if you want to print the binary form, you will have to do something like this, that is called as integer dot to binary string, and you will pass the value, the one that you want to convert, that is this. Okay, that is all. So we are going to run this. Hopefully there's no error. There's no error. So suppose I'm going to enter, let's enter the same thing. So you can compare 1011, right? So there you go. Okay, this is your answer set. If you don't want to print these two, which is completely fine, the max val and this, because it is not a part of your output, so I just did it to show you. So you can just skip that and just print this binary string. All right. Infosys question. So it says that you are given a string consisting of lowercase characters. The letters can be duplicate or non-duplicate. Duplicate letters have multiple copies present in the string, where the non-duplicates are unique and occur once. Your task is to return the index of the first non-duplicate letter present in the string if we traverse from left to right. So it's given the direction also. Using the indexing starting from 1. There is no such letter present. If there's no such letter present, then return -1. Okay. Pretty simple. What will you do is you will first take a map, make a hash map. You will have the key value pairs. Okay. Your key will be the letters and your value will be the number of times they have occurred, or rather their frequency. Okay. And once you're done with that, you're going to just iter once again. Okay. You will just iter once again and you are going to just see which key value pair, which key has the value 1, which one comes first, and that's what you have to return. Now suppose we consider this first word statistics. Okay, so what will we do? We'll have s. Okay, it has occurred once. Then we have t, that is occurring once. Then a, that is occurring once. Then we have t again. So we are going to change this value to 2. Then we have I, that is occurring once. Then we have s, so we'll change s value to 2. Okay, then we have t again, so we'll change that value to 3. Then we have I again, so we'll change that value to 2. Then we have c, so that is occurring once. Then we have s again, so we'll change that value to 3. Okay, so this is our map. Okay, this is our map. Now what will we do once this is done? We are going to iter over again once again, and we'll see, okay, s that has occurred 3 times, then t that has occurred 3 times, then we'll find a that has occurred once. We are going to end there the moment we hit a key value pair where the value is 1, and we are just going to return a. So technically if you see a, then that has occurred once, and that is the first letter that is occurring once. Okay, suppose we have a word like god. Okay, so you'll make a map. G is 1, G is 1, O is 1, and D is 1, right? Then what is the value over here? It will write it and it will return G. Okay, that because that is the first occurrence where it is 1, right? Now suppose you have a value like A, B, B. Okay, so your A is occurring twice, B is occurring twice. So what will it do? When it iters again, it will see, oh, this is 2, this is 2, and it will be the end of the map. So what will it return? It will return -1 in that case. Okay, so it is not difficult, but you need to keep one thing in mind, that use the indexing starting from 1. So your index is not starting from 0, it is starting from 1. Now here we are going to solve two questions, one in lead code and one normally. The lead code one does not have the index specification, so you will start that from 0, while the other one you have to start it from 1. It's just a single modification. So we are going to start with the lead code question, which says that you're given a string s, find the first non-repeating characters in it and return its index. If it does not exist, then return -1. Okay, so you basically don't have to change the index. You just have to start the index from 0. So this is going to be simple. We'll start it here, sorry, here, and we'll take a count. Okay, and that will be our map. Now, what are we going to do is we are going to do for character in your string, that is s, you are going to do your count character, okay, which will be equal to your count dot. We are going to use the get function, get character, comma, starting with the index, whatever it is there, okay, and then you'll just add 1 to it because you got that character, right? We are incrementing the count. So now you'll run again for I in range. I missed in. I in range. What is the range? Basically the length of your string, that will be the range, okay? So if count of s of I is equal to your 1, okay, wherever you get that 1, then you're just going to return that I, okay. I means you're returning the index, okay. And what will be the final thing? It will, if you haven't found any, just return -1. Why you're returning the index? Because it says that you have to return its index, okay. Here in the question, it did mention that you have to return the index. If you see here, okay, return the index. So it's not going to return a, but rather the index. So that will be 3 over here in this case. That is why the output is 3, okay. And similarly here also probably c, so that is also 3, okay. So yeah, we go back to this and we'll run this. That is accepted. We go ahead and submit this. So what will be your time complexity for this? Time complexity will be big O of n, and your space complexity will be big O of n as well, because you're storing the map, right? Okay, why will this be n and not n squared? Because this is going to run for n times, and same again, this will also run for that n times. So basically it is 2n, and we don't consider the constant value, so it can be reduced down to big O of n. Okay, now let's actually code what it's asking us to do. So suppose we define a function called as the first unique character. Okay, and we are going to pass the string s. All right, so we are going to do count. It's going to be the same thing, okay? But I'm still going to write that in for you here, or I'm just going to copy it from here. That would be better. Okay, so we copy and paste. All right, so this is not nested. This is outside. And this also we need to adjust. Okay, so we have it. And okay, we need to adjust this also. All right, so it says that your index should start from 1 and not from 0, right? So if you just return I, that means it is starting from 0. If you want to return from 1, that means you need to add 1 to that index. Okay, so instead of 0, it will count it as 1. And finally, when you are done with all of those, guess I came a step ahead. We are going to return -1. Okay, once you are done with this, you will take your input. How do we take input? We take normal input like this, okay? And then we'll do print this. So if we connect the Colab and we run this and say we enter statistics. So it's going to return 3, okay? If you enter God, it's going to return 1. Why? Because it is 0, all right? If you enter, what do I enter? Say AABB, is going to return -1. Why? Because both are repetition. Now, if I just return do A, then it will return just 1 because that is the first occurrence. Okay. So yeah, that is it. And the time and space complexity still remains the same for this code. So I hope that you have understood this question. So just a slight variation that they wanted the thing to start from 1, while in lead code you have the same question, but it doesn't want you to start the index at 1. It wants you to stick to 0. All right. So we'll do the same thing in Java. So we have the basic structure by given by lead code already. So we're going to take a map and we are going to pass the characters, comma, integer. Okay, we are going to do this and we will count, make a count, like call that variable, that map as count, and we'll do new hash map. Okay, so this is what we are going to do. Then we do for and we run character C to S, which will basically be the character of that array that we are considering. So you're going to count the frequencies now. Now, how will you count the frequency? You basically do count dot and use the keyword put p, whatever the count is, to where? To count dot get. So this is basically written like this or default. Okay. You're going to do this and you're going to do this. Okay. Now, once you're out of this loop, you are going to run another loop that will run from I. We need to put this as int I is equal to 0 and I will be less than s dot length, or I mean the length of the s dot length. Okay. And I plus plus. Now, what are you going to do in this? You're going to compare that if that value is 1 or not. If the count is 1, then just return that index. If not, you're going to not return anything, rather return a minus 1. Okay. So what will you do? You will do if your count dot get what? You need to get the s dot character at I. Okay. If this is equal to your 1, then simply return I. Okay. Otherwise, what are you going to do? You're going to return minus 1. Okay. That is all that you have to do. Now, since this is a lead code question, the lead code does not ask you to start the index from 1. It starts, just says you return the index, so you return 0. But if you execute this, you're going to do the exact same thing, but instead just add a plus 1 over here. Okay. So it will count the index from 1. So go ahead and submit this, and I guess this should be accepted. Oh, there's a compile. Oh, okay. I see the mistake. Sorry, that's just a typo error. And there's a typo again. So which line is it? Okay, get count dot get s dot character at. Oh, I wrote chart. I'm sorry. Okay, so that is accepted. We'll go ahead and submit this, and it should work. Okay, so I'm not claiming this to be the best algorithm, but definitely you can try and improve this even much better than this. Okay, so if you can do that, awesome. Let me know if you have any questions regarding this. So you are playing a card game when n uh, where n cards of different colors are arranged in a list on a circular table. Okay. The player must move one card at a time, either to the left or to the right. Since the cards are in a circular list, the last card is reached in either direction. The next card is at the other end of the list. So basically, if this is a circular arrangement, you have card 1, 2, 3, then you have 4, 5. Like this, it is arranged in circular format. Okay. So if this is the first card, then once you come to the end, this is going to be the last card. So you can access this first card in any way, right? So you have to basically determine the minimum number of left or right moves is required to reach the target card. Okay. Now suppose now suppose it's not circular. We just open these up and these are like this. Okay. We just imagine it's a circular string and you open that string, make it straight. Okay. So now this will be arranged like this. Okay. So do you really need to use a circular linked list? I don't think so. Okay. You can simply do it by making it a normal list. Okay. By just accessing the value. What will be the different conditions for these things? Okay. Just let's understand that. First condition would be when your end card is equal to your start card. Okay. That means they're actually in that same position. You start from this side, you go all the way here, and you come back to this. Okay. In that case, what will be your minimum number of moves that you will do? 0, because your start and your finish is same. So your distance traveled is 0, right? Or whether you go like this and come back, or you just do this, nothing but you start and you finish there, it's going to be 0, right? Now, if your start, if your start is at a difference like this, suppose your start is suppose we have these. Okay, this is your start, this is your end, right? I mean, if it's in a circular motion, you start like this and you come here, or you start like, I mean, you just travel like this, start to end. Okay, what will be the total difference? It will be start minus end, which will return, which will be equal to 1, and so you have to return 1. Okay, if the difference is just 1. Okay, otherwise there are two more conditions. Now consider if your card, okay, if your start card, sorry, if your end card is after your start card, something like this, your end card is after your start card. Okay, then what you have to calculate, you have to calculate the distance in both the direction, in the forward direction like this and in the backward direction like this. Okay, you have to do both. So if you do that, what will be your forward? Basically your forward will be very straightforward, right? It will be basically the difference of end position and your start, right? Why? Because your end is greater, your end is after your start. So end minus start. What will be your backward? This is slightly tricky. What will be your backward? Your backward will basically be, now just consider there are these cards A, B, C, D, and you have to travel from here to here. Okay, this is your start, this is your end. So you have to calculate the distance of A to B. That means from whatever the position is from 0 to this start. You have to find that. And you have to find the distance of these two from the last, like distance of E from n minus 1. Okay, and then you will do plus 1. Why plus 1? Because you want to move this also, right? This or this. Okay, it will be plus 1, correct? So suppose this distance, what will be this distance? This distance will nothing be S. Why? Because S minus 0 is going to be S, or wherever that index is, right? So it's going to be, suppose we name this as D1, it will be D1 plus, suppose this difference E minus of n minus 1, n minus 1 because that is the last index. Okay, so that, suppose we call that D2 plus 1. So this is going to be your formula. Okay, the other case will be, what will be the fourth case? This was when your start, when your end is greater than start. Now if your end is less than start, it will just be reverse of these two. So basically your forward will become D1 plus D2 plus 1, and your backward will become end minus start, or you can just change it like as start minus end. Okay, or you can just take mod. Okay, here mod, I meant this mod, that is where you just take the actual value, okay, and not the negation sign. So you're going to implement this thing. So now if you see the example, the first one is 4, that means there will be 4 color cards. You see these are the 4 color. Now you're starting at a particular index 1. Okay, you're starting, it says, right, that you have to move one card at a time and either to the left or to the right, and there is no going by, you can't go left and right. So 1, that means this is 0, this is 1, this is 3, this is sorry, this is 2, this is 3. Okay, and it's starting at here at 1, this is your start, and what is your end? Your end is yellow, this is your end. So how many things that you need to move? You need to move 1, then 2, right? So in forward direction it is moving 2. And which formula you're going to use? Formula number 3 over here. Okay, when your end is greater than your start. Okay, 3 is greater than your 1. Okay, your E and S is basically the indexes, okay, or the location. Okay, so the forward is 2. What will be your backward? Backward will be this distance, that is 1, plus by default we have to add 1, plus your E minus of n minus 1. So basically both of them will be 3, minus 3 it will be 0, so again it is 2. So minimum of 2 and 2 is 2, so it's returning 2. Okay, similarly if you do it here, so you are starting at index 0, 1, 2, 3, you're starting at a red. I guess I should just get rid of some of the things over here. I will not get rid of the formula though. Okay, so I'll put it up back here. So you're starting here at 3, this is 2, you're starting at 3, and you need black, right? You need this. So if you move in forward direction, then 1, Now, if you see, your start is greater than your end. So that means this formula. So this one will basically be the bigger one. So this will be the distance. What will be the distance? It will be 1 plus, what is the distance of this d2, the difference from the start? It will be 0 because it's the same one, plus 1. It will be 2. Okay. Then if you go in backward direction, so it's basically your start minus e. So that will be 3 minus 0, which will be 3. Correct. So in forward direction it is 2, in backward direction it is 3. So what is the minimum distance? 2, right? So you're going to choose this way. So that is why the output is also 2. Okay. So we will code this, and it's not simple if you just write down those four formulas straight. Okay, so suppose we have something called as the end. You know what? I actually have to define a function also. So shift cards, let's call that. And then you will have something as cards. Then you will have the start index. I will just consider it to be S. It's too lengthy. And then you will have your target or your end index. Okay. We'll use target because target is mentioned there. And then we'll take our E is equal to your card dot index the target. Okay, whatever the target is. Your n is nothing but the length of your cards. Correct? Now, if the first thing, if your end and your start both are equal, then what are you going to do? You're going to return 0. Correct? Else, or you can just write it like this, that if your the other one was like if your both the index have a difference of 1, right? Your s and your, we take the absolute value of s. Why is this? S minus of e. If that is equal to your 1, then you're going to return 1, right? Now you're going to have the main, both the other cases. If your S is less than E, then what you're going to do? You're going to do forward equal to E minus of S, okay? And your backward will be equal to your S. Why S? Because 0 to S will be the difference of S only, right? If you're traveling from 0 to 3 or 0 to 4, what is the difference? It's 3 or 4 respectively, right? The other one will be your N minus of 1 minus E, correct? And then you will just add 1 for the other displacement that you will have. Finally, what will be your else part? Else part is where your E is less than S, okay? So you don't have to write that. You can just simply put it up as else. So you'll have forward is equal to your, again, end index plus y end index, because now your e is closer to 0. Okay, so you will do n minus 1 minus s and add 1 for the displacement. Okay, and what will be your backward will basically be your s minus ey, because here your s is greater than e. Okay, now once this is done, you're simply going to return the min of either the forward or the backward. Okay, that's it. Now we'll take the input. So suppose you have to take the input n, so you will do n input. Okay, then we have to take input as cards, which will be equal to your input. Now these are the names, so you're just going to do it a split from the space. Okay, then you will have your s, which will be equal to again your integer input, because that is the integer index that you want to start with. You will have your target as equal to your input again. Now target is again a string. Okay, and finally, if you want, we can just print, we'll call that whole thing. Okay, right? So we are going to go ahead and run this. So if we enter the values that we were given, like 4, then we had probably red, blue, green, and yellow. And we want to start with index 1, and we are looking for yellow. Okay, so it should return you 2, right? So I hope you have understood this question. I will zoom out for a moment so you can see the whole code. All right. So yes, this is exactly how you take the input and how you will work on this question. So if you want to find out the time complexity, that will be big O of n because it's having n number of cards. And space complexity will basically be nothing because we are not storing anything, we're just returning a min, right? So we are going to create a function first called as the shift cards. For in Java, we'll create it like we did in Python. And we'll say that it's int shift cards, and we'll have a list of type string. Then we'll call that as cards. And what else parameters do we need? I guess we need int start index, or just call that s, it's too big. Okay, and we need one string called as the target, right? We are going to do this. Now you can take an int e, which will be equal to your cards dot index of what? Of target. Okay, of target. Now once you're done with this, you're going to do int n is equal to your cards dot size, whatever the size is. You are going to check if your e is equal to your start. Okay, if it is true, then you are returning. If this is true, you will return. What will you return? If this is true, you will return 0. Okay, if not, if your e is basically like if they are both at a difference of 1, right? So what will you do for that? You're going to use this math function, okay, in which you're going to find the absolute value, math with capital M. So math dot abs, that is the absolute value. You're going to do s minus e, and you're going to check if this value is equal to 1. Okay, if this is true, you're going to return, 1. Okay, now these are the two test cases that we just saw. Now there are two more, right? So we are going to take two values, one is forward, one is backward, and we are going to start writing the third condition where your s is less than your e. Okay, this was the condition. So what will be your forward? Your forward will basically be equal to your e minus s, right? That will be very straightforward. Now what will be your backward? Your backward will be your start index, that is your s, because the distance is being calculated from 0 to s, so that is s only, right? Then n minus 1 minus e, right, for the backside. And then you are going to just add 1 because you're going to make that one transition from 0 to, sorry, yeah, from the 0th index to the last index, right? So I'm going to just add space because Java can be annoying at times. Okay, so now once this is done, you're done with this. So you will exit this. You have just one more thing left. So you'll put that up in the else part. Now your else will basically have forward. Now it's just the reverse of this. So it will be E plus, what are you going to do? It will be N minus 1 minus your start index. And you're going to just add 1, right? And what will be your backward? Your backward will be your start index minus E, right? So once you are done with this, you are going to exit all of this and you're just going to return the minimum, right? So you're going to use the math function again, or the class. Use minimum of whether it is a forward or a backward. Okay, whatever the min is, you're going to return that. Now, we didn't write one thing, that is the main function. So we write here public static void main and your same string argument to be passed. Okay, so in this, what will you take your input as? Scanner sc equal to new scanner, right? That same old line for taking an input. Once this is done, you are going to do it as integer dot, sorry, for the capital, it will be parse int, and you're going to do se dot next line. Okay, so this is going to be your number of cards that you're going to have. Then we'll take the list And what are we going to pass? We have taken the list type to be string already while defining the function, right? So it will be called as cards. So these are basically the cards of the, like, whatever color cards you're taking. So you will put it up as arrays as list, and you will do the same thing next line. But remember that you have to split it here because you're going to enter the value in a single line. So how will you split it? You'll split it from the space. Okay. Now you have one more thing, that is the start index. So int s is basically going to be your uh, integer dot parse int. It's going to be same like how you have taken the input for your number of cards. So it will be se dot next line. Okay. Guess that's it. And I guess one more last thing that we have, that is our string typed with the target, whatever the target card is. So you're just going to do se dot next line. Okay. That's it. And once you're done with this, you're just going to do a print on the final output. So that will be print ln. And what are you going to call? You're going to call cards. And once you call, I guess the function name was shift cards, right? Shift cards. And what are you going to call inside this? You're going to call cards. You're going to call the start index, and you're going to call the target, right? Once this is done, you are almost there. Just close this. Pretty advisable to do it, and that is it. Okay. So go ahead and run this. Oh, my bad. System.out.println missed n somehow. So we're going to run this again and we'll see. Perfect. So we'll now enter say 4. Then we have red, green, blue, and yellow, right? Then we have 1 and we have yellow. So it should return 2. Okay, right? So not that difficult. It's the same code that we wrote in Python. You just need to tweak few inputs here and there, and there you go. All right. So this is a medium kind of a question. It's not that easy, not that hard. So it's called the minimum processing time. So basically, as we know that every computer has a processor and every processor has a fixed time in which it can execute the tasks, right? So exactly the same thing has been put up for you in words. What you're given is that there are certain number of processors, each having 4 cores. Okay, so you know there are quad core processors that laptops or any system uses. So every processor is having 4 cores. Okay, so assume that simultaneously 4 tasks can run on a single processor at the same time simultaneously. Okay, now number of tasks can be executed is 4 times the number of processor. Obviously, if one processor has 4 cores, that means one processor can simultaneously run 4 tasks, right? So each task must be assigned to a unique core, and each core can only be used once. You are given an array of processor time representing the time each processor becomes available, and the array task representing how long it takes for each task to complete. Return the minimum time needed for the task to complete, for all the tasks to be completed. Now, this is your processor time. This is your tasks, and the output is 16. Now, how did we come to this solution? So I'll take my processor time to be P, and I have them as 8 and 10, right? And my task time, I'll consider it to be T. I have it to be 2 to, I don't remember exactly, but maybe this was something that we had. Okay, let's just assume this. Okay, now what will be my, it says what is the minimum time needed. Minimum time means the largest process, whatever the largest process is. If I put that up with the processor who's consuming less time, then my code will be optimized, right? For example, like let's take a real world example. Suppose I ask my mom to cook food and I cook food, right? So who's going to do a better task at cooking food and who will be quick? My mom, right? So my mom will take less time and give me the optimized solution. So similarly, I'll take the task with highest execution time and pair it up with the processor that is going to take less time. So how will I do this? First step should be that this should be sorted in ascending order. Okay. And the task should be sorted in descending order. Why descending? Because we want the highest time taking task to be at the first place. So we can just keep assigning it. Okay. So what will happen? So if I sort these, my P will be 8 and 10, like as it is, and T will be 8, 7, 5, 4, 3, 2, 2, and 1. Okay. Now what will I do? Each processor has how many cores? 4 cores, right? So this means these 4 will belong to processor which takes 8, and this will belong to the processor that takes 10 processing time. Correct? So now what am I going to do? I am just going to, now this is arranged, right? This is sorted in the ascending order. That means this processor's maximum time will be this plus this, right? For this processor, the maximum time will be this plus this. Since this is in decreasing order, these all will be having a lesser value, correct? So what will be the processing time over here? The maximum processing time will be 8 plus 8, that will be 16. And here the maximum processing time will be 10 plus 3, that will be 13. Okay. Now, from these two, which one is having the highest value? This. So, what will be the minimum time needed to complete all the tasks? It will definitely be 16. Okay. I cannot take 13. You will now wonder, ma'am, but it said minimum, right? Yeah, minimum. But we need to complete this task, right? This task is inclusive of the highest task as well. So, we need to complete all of them. So, I basically need to figure out which task is taking maximum time, and that will be the minimum time required to complete all the tasks. We need at least 16 minutes to complete all the tasks. Right? Fair enough. So, two things. First, sort them and then do the addition of the zeroth index with the processor time or processing time, whatever it is called. Okay. Now, if there was another extra value, say there was a value called 11, okay, and we had another set of values over here, say 1, 1, 1, 1, and 1. So, what would I do? I would do it as 11 plus 1, that would be 12. Okay. Now why is this all 1 1? Why didn't I write any other number? Because this is in sorted in descending order, right? If I would have written any other number, would have messed up my sorting. So since it's sorted, keep that in mind. Okay. So even here also, now the total is 12, so it doesn't really matter. Our maximum is still 16, so the minimum answer that will be returned will be 16. All right. That is the same example that has been solved over here. All right. Now let's see how we can code this. Now coding this is not a big challenge. I'll tell you why. Because you already know what you're doing, right? So first you need to find the length of the tasks. Then you have something called as the processor time that is given already. So you're going to do a sort on that. Okay. And then you already have something called as tasks. So you're going to do sort on that also. Okay. We are going to first sort both of these. Now, once these are sorted, you're going to take a variable, say j, which will be equal to your n minus 1. Okay, whatever the length of the task is, minus 1, you're creating this array. Now, your m is equal to length of the processing task. Sorry, the processor time, not the processing task, the processor time. Okay, you will store your answer, suppose, say, in this answer variable. We'll now run this loop I in range of m, right? The one that has our processing time or processor time rather. Okay. Then you will have a counter C. Why will the C be the counter? Because you need to keep track that it is still four cores, right? So this should be less than 4 and your J should be greater than equal to 0. If that is the case, then in your answer, you're going to just figure out which is the max, whether the answer or the the processor time. Okay. Now, not just the processor time, but the processor time at that given location for that particular task. Okay. Because you're doing it individually for every single task. Okay. Once that is done, just increment the core value or the counter, whatever you want to call it. And you need to do a minus on your task. Why? You just finished doing one task, right? And at the end, why everything is complete, just return your answer. Okay. So this is the whole code. So let's go ahead and run this. Oh, why is that? Or runtime? Did I miss out on something? ANS. Okay, okay, I got it. It is not task, it is tasks. Oops. So we'll run this again. Yep, so that is accepted like you see. We go ahead and submit this. So what is the time complexity? Time complexity is little tricky over here. So if you see, we are doing two sort, right? So this will be, suppose m elements, so m log n times this will going to be sorted, right? And this one will also take n log n, right? Plus you have this loop. So this is going to run for n times. So you are going to basically have m log m plus n log n plus n. Okay. So this is your time complexity. You can ignore this n because it's almost a constant. So your total time complexity will be m log m plus n log n. Okay. And what will be your space complexity? Now your space complexity will be either a constant, or if you choose to say that, oh no, we are storing this sorted list, so it will be m plus n. So it completely depends on what do you think. Most of them will say this m plus n, but if you say it's constant, it's fair enough because it's not something that you are forcefully doing, but it's rather something that you have to return it as a part of your output. So we are going to do the same code in Java as well. So it's going to be more or less the same thing, just that the syntax will change a bit. So it will basically be task.size. That will be your n, and oops, I'm sorry, semicolon. Then I'm going to use collections to just sort my processor time and my tasks. So this is processor time. And this, once this is sorted, I'm going to sort collection dot sort, and it will be my tasks, right? Okay, so once this is done, I'm going to run a take a value j, which will be equal to n minus of 1, and I'll take a value, say m, which will be equal to processor time. So basically, it is the same code, okay? Dot size. So this is going to be whatever the processor size is, and we'll take a variable for the answer, okay? Where we are going to just store the answers. So once this is done, you're going to now run your loop, that is int of I is equal to 0 and I less than m. It's not n here, it's m, okay? And you're going to take a count, that is going to count the number of cores that we have. So we have 4 cores. So we are going to run the loop accordingly. So while c is less than your 4, that is 4 core, and your I'll give some space so you can have visibility in reading it, and your j is greater than equal to 0. Okay. Now once this is the condition, you're just going to do your answer is nothing but you're going to call the math function class, and you're going to do max, whether that is the answer or the processor time. And how we're going to write this? Processor time dot get I plus your task, that will be j, right? So tasks dot get j. Okay. So with this, you're going to increment your count, okay, and you're going to decrement your task. Okay. So once this is done, you're out of this loop. You're just going to return your answer. Okay, we go ahead and run this. So this is accepted, and we can go ahead and submit this in order to just see that it's accepted. Yep. Okay. So definitely, if you have better answer than this, go ahead and solve it. If not, you can stick to this one. It's not a bad one. All right. We do have many lead code questions that are similar to this. So I'll give you that information at the end of the question. All right. So it says that you are given a string s of size n. You have to perform a particular type of query. You have to perform a particular type of query. The query will be given to you. That is right here. Multiple times. Okay. On the string. The query is that for any string t, find the length of the lexicographical. Now, lexicographical means something that we'll understand in the example down below. Okay, smallest suffix string of s that starts with t. If there are no suffix, then return 0. And performing all the queries, you have to return the sum of all queries. Okay, since the answer can be in very large, that's okay. That's the constraint. Okay, so here your input is 13. Okay, and this is your entered query. Okay, length of the string is 13. This is your entered query, and you're just entering one suffix, okay, the lexicographical suffix. You're just entering one lexicographical suffix. So this is the length of the string s, and this is the number of query. Okay, so this is your query that you are entering, and this is the string. Okay, so now you have MZADPOGHYYK and T, right? Now what's your query? YK. Where do you see YK? Over here, right? So what will you return is you have to return the entire string starting with YK till the end. Okay, so what is the total number of letters over here? 4, right? So your answer is 4. Okay. Similarly, here you have 12 characters and you have two queries, that is Z and W. So if you start with K, T, M, R, G, J, S, W, H, W, X, and U, you enter Z and there is no Z. So this Z will return 0. Okay. And for this W, what will you be entering? So you find your W over here, right? This is the first occurrence. So starting with this, you have to do it all the way till the end. Okay. So this is 1, 2, 3, 4, and 5. So this is returning 5. So 0 plus 5 is 5. Your output is 5. Okay. Similarly, you have T, V, T, R, P, U, D, O, S, N, L, Y, D, G, I. Okay. And just one query. I guess I missed out writing the query. The query can be, say, suppose DO. So you have DO over here, right? So starting with DO all the way till the end. If you count, it is 1, 2, 3, 4, 5, 6, 7, 8, and 9. So I guess that's your output. 9. Okay. It's not difficult at all. Just if you know how to code it. It's pretty simple. And now we'll see how we can code this one. So starting with the input, let's take an input, say A, maybe. Okay. And we'll put it up as an input because this is going to be your main string that you're going to enter. Okay. And we won't do a lot of fuss over here. We'll keep it simple. If you want, you can also take the input as your number of like your these first two. If you want, you can do that as well. 15 and 1, this was just for your reference. You will just be given the string and the query. Okay, that is what is mentioned in the question. You are given a string of size n and there's a query that you have been provided with. Okay, you won't have all of the other things. So this will basically be your query input, so which will be equal to your input again. We are not going to pass any statement because this is for an online assessment question. So next we are going to do that your query is equal to q input dot split. If you want, you can put it up at the same line. I didn't do it just to show you that this is something that you can do. We'll have our answer stored in answer, where we'll have the total number of elements that we are going to have. Now for I in the query, okay, we are going to iter over every element of I. Like here we had y and k in the first place, right? You had y and k, so you can iter over. In the third we had d and o, so you can iter over it. Okay, so for all of that, you're going to use a variable, say k, and what is the input string? Input string is a, right? So in a we have to find, and now find by default is a function in Python, so you can use that function. It will help you locate that I character that you are looking for in a. Okay, wherever it is. Now next what you'll do, now if this k is not found in your a, that means it is equal to -1, you're simply going to do answer is equal to answer plus 0. Okay, else is found, what will you do? Then your s, okay, any variable s or just a string, whatever you consider, will be the length, the new string that you're forming, that the final thing that will be appended to the answer and that will be returned. So it's basically the length of the, it is basically length of this whole thing once you have found that query, right? So it will be the length of a starting with k, okay, whatever the k is, wherever you found it, all the way till the end, right? So if I just put a colon and don't write anything, that means it's all the way till the end. Now my answer will be answer plus s. Okay, so I'm just going to add that and finally print your answer. Okay, once you are done with that, I guess we are good to go. We'll run this and say my input is, we'll put up the same thing, maybe MZADPOGHYYKHNT. Okay, and your character will be this. So you have got your answer as 4, right? So it's starting with YK together because it's together. Now if we run one more where we had two inputs, right, like the Z and the thing, so how do you do that? So you will basically, if you see in your input, you have taken it to split, right? The split means it's going to split from the space. So first of all, let's try doing this. M R G J S W H W X U, okay, and Z and this. So it's going to return us 5, okay? So if you're passing two queries, make sure they are separated by space, okay? I hope that this question was helpful. And before I exit this, what would be the time complexity? Pretty simple. It is big O of n. I'm sorry, I guess I hit the wrong enter key. And your space complexity will be equal to a constant, okay? You're not really storing anything. It's just a couple of executions, so this is going to be a constant. All right. So you have your code over here. I hope this video was helpful. I will see you in the next one. And before leaving, as I informed that we are going to talk about the lead code that you can solve. So there are multiple lead code questions that you can find on lexicographical suffix or lexicographical strings. So you can definitely go and check those out. You can get a list of those online and you can try those out on yourself and let me know how they go, right? So for this one in Java, what are we going to do? Again, we'll take a scanner. Oops, I'm sorry. Scanner class for input. And what are we going to enter here? So we are going to take the main string as input. So we'll do the normal system dot in. Okay. Okay, this is slightly annoying me. I get this down. Okay. Okay, so once this is done, we are going to basically take a string input. So say string A maybe, which is equal to your se dot next line. What are you going to enter over here? You're going to enter your main string, the actual gibberish or whatever string you want to enter to just find out the thing. The next one will be called as the say Q input for the lexicographical thing that we are going to consider. So we are going to do the next line here as well because both are in string format. Now, once you're done with this, what are you basically trying to do? You're just trying to make sure that you convert the input string into a list of substrings, right? So suppose I will do string and let's call this a Q. So you will have Q underscore input, the variable that we have taken, and we will split it. And how do we split it? We split it from whatever the S thing we have, okay? From there, we are going to split it. Now, we'll further see this in details shortly. So, we are going to do answer is equal to 0. Now, what is the next step for this? So, you have to run this for loop of string, right? For I till I'm sorry, all the way till the value of Q, okay? Wherever you find that Q, what are you going to do? You're basically returning K, right? So, what is K? K is nothing but the index of that, right? So A dot index of I. So once you are done with this, you're going to check one more time that your K is equal to -1. Okay. So once this is true, what are you going to do? You're going to do answer plus equal to 0. Okay. Else, I'll scroll this up. Else, you have another condition where it's not equal to -1. Oh, I'm sorry, I just wrote the wrong syntax. So here we'll put in S is equal to A dot length minus K, right? Now what will be your answer? Your answer will be equal to S, okay? Right? Now once you're out of this loop, do a system dot out dot print ln and just print the answer. That's it. I would insist on closing the scanner class as well. Okay, and just go ahead and run this. So if we had to enter the string, suppose I'm entering the same string that was MZADPHO, pretty unique and weird name, but yeah, it is what it is. And now we are entering the Q that we have, and it's going to return us 4, right? So it's going to basically consider this half. Okay. I hope you have understood this question. Wasn't that difficult? It was the same implementation as we have spoken in the explanation and we have seen in the Python code, right? Sorry, Infosys level question, my bad. So it says that find the mode in the binary search tree, okay? So the biggest hint is that it is a BST, okay? and you have to find the mode. Now, what does mode mean? I'm sorry, I opened another tab. So, mode basically means the most frequently occurred element. That is what the mode is, and that is all you want to know. If you want to read the article, you can definitely click here and you can go there, okay? So, it says that a tree has more than one node, then you can return them in any order. So, if there's a tree where there are, suppose it says it has 2 and 3, and both of them have occurred in same number of frequency and they are maximum, return them as 2, 3, or 3, 2, doesn't matter. Any order you can return it, okay? Now, so assume that there's a BST. We know that BST's left side is always the values that are less than or equal to, and right side has values that are greater than or equal to, okay? And both the left and right subtree must also be BST. So this is 1, 2, 2. So what will you return? You will definitely return 2. Why? Because 2 has occurred maximum number of times, right? So if we go here and we look into this BST, so this has 5, 3, 2, 3, 8, 8 and 8, right? So we know that for BST it is always an in order traversal. So it is left, root and right, correct? This is the thing for BST. Now by looking at this tree, you know which one is maximum. So what will you return? You will return 8, correct? Now, if we do the in order traversal, what will be the values? So it's going to be starting at the root, right? Then the left, that is 3. Now, does 3 have a left? Yes, it does. So it will write 2 first. Then 2 has nothing. So we'll go back to 3. So it will be 3. Now, does 3 have a right? Because it's the right. Yes, it does. It will be 3 again. Now, 3 does not have anything any further. So it will go back to this 3. Correct? Now, this 3 is the left of this 5, right? So we have already written this 3 over here. So we are not repeating that. It will go back to 5. Now we'll come down to the right side, okay? 8. Does 8 have a left child? No, it does not. So we go to the right. So now this one, does it have a left? It does. That is 8. So we are going to put 8. Now this will get returned to this 8. So this 8 will come here. Now does this have a right child? No, it does not. So it will go back to this 8 and finally to the root that we have already included in this. So this is the in order traversal, right? Now we will consider few values. First will be the previous, which will be assigned to none. Then you will have something called as count that will be assigned to 0. Then we'll have max count. Okay, I will explain all of these slowly, and then we'll have finally the modes, which will be a list. Okay, now once we have this order, okay, since this is in order, we are going to start with this node first. Okay, this value. So 2, right? So what will happen? It is going to iter over this entire list that we just created. First value is 2, correct? Now, has 2 occurred anywhere over here? No, it did not because we are the start. So, what will happen to the count? It will be 2. Sorry, it will be 1. Okay, so 2 has occurred once. Now, what will your max count be updated to? That will also be updated to 1, correct? Now, what will your mode become? Your mode will become 2. Why? Because that is the maximum that we have seen so far. Okay. Now this will shift to this, but before shifting, this none will change to what the previous one was. That was 2. Correct. Now we'll look into this 3. Now 3, has it occurred previously? No. So this value will be reset to 0. Okay. But we'll not change anything with the max count. Max count is still 1. Okay. Now 3 has occurred. So 3 has occurred how many times till now? Just 1. Fair enough. So we'll move to the next 3. So that has, it is the same 3. So this one will be updated to 2. Now when this is updated to 2, your max count is now going to get updated to 2 because 2 is greater than 1. What will happen to your mode? Your mode will have 3. Okay. Okay. I missed one thing. So let's go back by one step. So before moving to the previous value, okay, so this max count was 1 after 2. So now we got 1, 3. So this will become 3. Okay, correct. So now this 1 and this max count are same. So that means we'll add 3 to the mode. Okay. Okay. Now, when we move to the next one, this count will be updated to 2. So this max count will be updated to 2. Correct. Now we no longer have the same values of 2 and 3. Now 3 is at a higher range. So my mode will only have 3. We'll get rid of 2. Okay. So we'll move to 5. Okay. What node have we seen here? This will be updated to 3. We have seen 3. Now 5. So 5 we haven't seen. So you're going to reset this to 0 again. Okay. Do not change the max count. Now, how many occurrence? 1. Correct. Now what will happen? It will move to next. So this will be updated to 5. So now 8. Have we seen 8 before? No, we haven't. So reset this to 0. Then again update that to 1. Correct? Now 1, do not change the max count. Now change this to 2. Okay. So 2, 2 are same. Correct? So that means we'll add one more element into the mode. That is 8. Now again move to the next 8. So this will be updated to 3. Now 3 is greater than 2. So update max count. Now we'll get rid of this whole thing. We'll just have 8. Now why do I have two characters when they are 2 2 same? Because we cannot decide who is greater, right? Because both are same values, right? So had this 8 not been there, okay, this last 8 wouldn't have been there. So it would have been 2 here and 2 here, right? So that means we would have had 3 and 8. So that is what this question said, right? In the last, if you remember, that if there are more than one modes, return them in any order. So we would have returned both 3 and 8, okay? But in this case, we have 8 more than 3. So that is why in the next step, when the count gets incremented, we no longer have 3. 3 is out of competition now, okay? So we are going to just return 8, okay? That's it. So we are going to now code this. Little lengthy, but I wouldn't say that it is difficult. We're going to start with self dot count, okay? We'll initialize that to 0. Then we'll have self dot max count. That will also be initialized to 0. Then we'll have the self dot modes, okay, which will be an empty list. Now we are going to define the in order traversal of the nodes. So what do you think will be the code over here? It will basically be if it's not a node, then simply return. You don't have to do anything, okay, because it's an empty, there's no existing node in it, okay. Otherwise, what are you going to do? You're going to do in order. And if in case you're just wondering that where did I get this node from, you see this is defined, okay. So I can just call that function, I mean the class, okay. So it will be node dot left, okay. Now you're going to update your counts. How will you update your counts? You will do if self dot previous is equal to your none, okay. Initially it was none. Now when you're updating it, what will it become? It will become the node dot val, okay. Then your self dot count will be incremented by 1. All right, and then you will have your else part. That means it's not equal to val. So simply you're just going to sorry for the spelling mistake. So you're simply just going to set your count to equal to 1, okay. And then you have to update your max count as well, right? So if you write the code, it will be like if your self dot count. Now this is going to do a comparison between the max count and the count, okay. If your count is greater than the max count, then you're going to just append that value to your max count. So your self dot max count is equal to your self dot count, okay. Just simply append that value or assign that value, okay. Then self dot node your self dot nodes will become equivalent to, sorry, not nodes, my bad, self dot modes. So your self dot modes will become equivalent to your node dot value, okay. We'll put that within the bracket. I missed it here. All right. And once you are done with this, you have another part called the else if part. So if your self dot count is equal to your max count, right? Where there's a probability where there can be more than one modes that can be returned. In that case, you're again going to do what? You're just going to update your modes, right? So your self dot modes will just be like append. And what will you append? The node dot value. Okay, that's it. And finally, when you are done with this, you're going to return your uh, self dot previous is equal to your node dot val. You have to update this, okay. And you're going to do the in order on node dot right, okay. So once you're done with that, I skipped it. So once you are done with that, I just will make the screen smaller so you can see the entire thing. So, yep, once that is done, you're going to just do in order and you're going to call root. Okay. If you don't call root, it's not going to run. So you're just going to return self dot modes. Okay. That is all that we need to return. So we will wait. So did I make a spelling mistake? So runtime error self.priv. Have I not defined self.priv? Yeah, I probably haven't defined self.priv. So let's do it here. Dot priv is equal to none. Okay, and now let's run this. Okay, so that's working. We go ahead and submit this. In the meanwhile, what is your time complexity? Your time complexity is nothing but big O of n. All right. So, yep, that's it. Now I'm just going to put it back to the same normal size. So this is your complete code. Okay. I know it's pretty lengthy, but I hope this was worth the time it took. So if we have to write this solution using Java, what will we do? We'll first initialize the variable, say private integer. Your priv will be equal to your null. Then we'll have private int count, that will be equal to 0. Okay, and what else we had? We had private int max count, right? That will also be equal to 0. Now we'll have one more thing, that will be your private, make that a list, and integer, that will be called as modes, which will be equal to your new array list. Okay, now we have this function to work with. So first thing first, we need to do the in order on root. Okay, so then we are going to create another result list or an array, whatever you want to call it. So it will be mode dot size, whatever the size is, and size is a function. So we're going to do this and we're going to run this loop now. So now this loop will run for I is equal to 0 to all the way till I less than the size of your modes. Okay, so it will be modes dot size. And what are you going to do? You're going to do I plus plus. Okay, and what are you going to store in this? Nothing. You're just going to get the result. And what will that be equal to? It will be equal to whatever your modes that you cover, or rather, I would say the nodes that you cover. Okay, so it will be same as mode of I. Okay, now once you're done with this, you come out, and what will you return? You will return your result. Okay, once this is done, you are going to actually write the function for in order traversal that you have used here, the one that you have called here in order on roots. You're going to do it here. Okay, say in order. And what are you going to pass? You're going to pass a tree node. Okay, tree node. Okay, now if that node is equal to null, what are you supposed to do? Simply return. Okay, and then what are we going to do? We are going to find the in order dot left. Okay, now another comparison. So if your previous, okay, the previous one is not equal to null, and we can use logical and over here, not the bitwise one, or you don't write and in Java. So it's node dot val is equal to your priv. If both of them are true, then what are you going to do? You're going to increment your count. Okay, else what will you do? You will just reset your count to 1. Okay, that's it. Now once this is done, you are out of this. What are you going to do? Now you're going to do another comparison. For what? You're now going to update the max count and the mode accordingly. So now if your count is greater than your max count, what will be your max count? It will be equal to your count. Okay, then you will assign your max count is equal to count. Okay, and what will happen to your modes? You basically going to clean that up. So you will do modes dot clear, because you're not going to use that, you're going to use the new one. So then you will do modes dot add. What will you add? You will add the node dot val. Okay. So this will be your one condition. The other else part will basically be, we'll put this as else if. Okay. So your else if will basically be your, do I have to write the condition? Yeah, I guess I do have to write the condition. So it will basically be count is equal to your max count. If that is the case, then what you're going to do, you are going to basically do modes. Just simply add it, no removal, just add that to the existing mode. Okay, whatever it can have. Like if you had existing 2, it will just make the mode get added by the next node, that will be 3. So it will become 2, 3 in the mode. Okay, you don't have to change anything. Okay, so that's it. And once you are out of that, what you're going to do, you're going to reset your priv to be equal to your node dot val, and you're going to just do in order on right node. Okay, node dot right. Okay, I'll just give a extra space here so it's just clear. Okay, so we go ahead and submit this. Okay, so that's working, so we can go ahead and submit that. Perfect. So this looks like a perfect code. You don't have to modify it. You can pretty much use the same code. Okay. Yeah, but if you definitely have something better than this, go ahead with that. Okay. And we have that direct question here on lead code, and it says that find the maximum consecutive number, not number ones. So basically it means you're given in binary array called nums. You have to return the maximum number of consecutive ones in that array. So suppose I take this is consecutive, this is consecutive, so maximum is 3, output is 3. Okay, how do we solve this? So suppose we have this array 1 1 0 1 1 and 1. Okay, so we are going to consider two things. One is the count, which will be assigned to 0. The other one will be your max count. That's it. That will be assigned to 0 as well. Okay, so we are going to iterate over the given array digit by digit. So this digit, if digit, suppose this is the array, so if ARR of digit is equal to 1, okay, if this digit is equal to 1, then you're going to increment your count. Okay, and so since this was 0 and the count is 1, so whichever is greater, your max count will be incremented to 1 as well. Now you move to the next one. This is also 1, so this will be updated to 2, and this will also be updated to 2. Got it? Now this is 0. Whenever we encounter a 0, you're just going to reset the count to 0. Okay, whenever you encounter a 0, reset the count to 0. Do not change the max count, because max count is still holding the count of 1. Okay, done. Now move to the next one. This is 1, right? So you will increment this. Nothing will happen to max count because max count is having the maximum count. So till now we have got maximum of 2. This is less, so we won't update this. Now move to this. This is getting updated to 2. Now both are equal, so it doesn't matter. Now move to the next one. This will be updated to 3. Now, when this will be updated to 3, you have to update this to 3, because maximum, again, whatever is max, this or the count. If count is max, then you have to update the count, right? That's it. This is it. And you just return this value. Okay. This question was given in a twisted way because they made a story out of this question. And overall, all you had to do is just this: keep a track, iterate, keep a track of ones. Whenever there's a 0, just reset the count and keep going. Okay, so we will see how we can solve this easily. It's a pretty simple code, not complicated at all. So we'll set count equal to 0, and our max count will be equal to 0 as well. Okay, now for, you can consider num in nums, or whatever you want to consider, because here the array name is given as nums. So I took num in nums just to keep it simple. Now if your num, okay, is equal to your 1, then you're just going to increment the count by 1. Okay, and what will happen to your max count? Your max count is nothing but the max of whatever the max is, whether it is the max count itself or it is the count. Okay, whatever is greater. Now if the value is not 1, then it will be 0, and whenever it is 0, just reset count to 0. Okay, now how do I know else will be 0? Because That is exactly what the inputs are. Okay, so pretty sure the input won't be anything other than zeros and one, and moreover it mentions that it is a binary array, correct? So either it will be one or it will be zero. So if I put one in if, the other one is definitely zero. Okay, so once you're done with that, just do a return on max count. Okay, that's it, and we go ahead and submit this code. It is accepted. What will be the time complexity? Definitely you are just running one single loop that is iterating over the given list. It will be big O of n, right? It was a very easy question, not at all difficult. I hope you have understood this. So let's solve the same question using Java. It will basically stay the same, just the syntax changes. So int count, then in int max count, both will be set to 0. Okay, and you're going to run a for loop where int of num is present in your given array nums. If that's the case, then you will check this condition that if your num is equal to your 1. Okay, if it is correct, then what are you going to do? You're basically going to increment the count by 1, right? So you'll do count plus plus. And what will happen to your max count? It will either be the max of, it will be the max of either the max count itself or the count, right? So what are you going to use? You're going to use the math library and you're going to write max and you're going to pass the max count and count, whatever is of higher order. Okay. Now, once this is done, you will have your else. What will be your else? Your else will basically mean that it is not 1, it is 0. So whenever it is 0, just reset the count to 0. Okay. That's all. And finally, once you're out of that loop as well, what are you going to return? You will return the max count. Okay. So if I go ahead and run this, that is accepted, and we'll go ahead and submit this to just make sure that that's working. It didn't exceed the time limit. Perfect. Okay, so definitely there are better codes than this. You can see people have submitted in much better time, so you can go ahead and give that a try, and if you succeed, very good, else you can just stick to my code. All right. Hello everyone, we'll be looking into another Infosys level question. Now this used to be a medium level question for FANG companies, but right now it has become favorite question for all mass recruiting companies, called the implementation of queues using stack. So basically, queue uses FIFO while stack uses LIFO. So it says that you have to implement a FIFO queue using only two stacks. So you have to just use two stacks, okay, and do it. And along with that, you should also implement functions like push, peek, pop, and empty. Okay. So these are all the conditions that are given to you, and you should work on it. So we'll just try understanding this in a better way. So suppose we have this queue, okay? I will denote this as Q, and Q uses FIFO, right? So this, and this. So let's have some numbers in here as 1, 2, 3, and then we have two stacks, right? So this is stack 1, which using LIFO, and this is stack 2, S2, that is also going to use LIFO. Now, what do we have to implement? We have to implement a push, a pop, a peek, and empty, right? Four functions. Now, first thing, if we have to do a push, okay, suppose we do a push. Say we pushing 1. Now, how will you push 1? Simple, you will push 1 here, okay, and let's call this as the in stack and this as the out stack, okay? So in stack and out stack. So whenever you're pushing, you push into the in stack, okay? Whenever you're going to pop, you will pop from the out stack, okay? So you pushed 1 into the queue, into the stack. Now suppose we have to push 2. Okay. How do we push in 2? We'll put in 2 here and we'll put in 2 here. Okay. Now there is no difference in pushing the elements onto the queue. They are pushed just the same way. Okay. Now once that is done, okay, what are we going to do? Suppose we are trying to do a pop now. Okay. We'll try to do a pop. If we pop, we are going to remove 1 first from here, right? And here we have nothing. So we first have to push these values into the out stack. So what will we pop from here? We'll pop 2 from here and that 2 will go in here. Then we'll pop one from here and that one will go in here. Now from here if we pop, then you see this one and this one is same, correct? Then once that is done, what will you do? Suppose again we want to push in a value, say 3. Okay, we want to push in a value, say 3. We'll simply push it in over here, correct? And we'll push it in here. But now again, if I want to perform an pop operation, what will I do? I'm going to first check if my out stack is empty or not. If it is not empty, I'm not going to push this here. I'm going to first pop this. Okay, why? Because in the queue, this is going to be popped first, right? First in, first out. So 2 will go first before 3. So I have to make sure my stack is empty before I push in a new element. Once this is popped, then I'm going to insert this. And then when I pop this, I can pop this. Okay, got it? So now if you want to do a peek, you can just peek into and see that, okay, this is empty, and this is empty, right? And finally, you can call the empty function just to make sure that these two are empty and these are also gone. Okay, so what time complexity can you actually solve this? Push operation can be done in constant time. Pop will take n times because how many pops you need to do. Similarly, your peak will also take n, while your empty can be figured out in a constant time. Okay, so it is as simple as that. Now you have already been given some function that has been written over here. You just need to complete the implementation. So in it means basically a constructor. So you are going to call the constructor that was in stack and the out stack. Now both of these are empty lists. Okay, that's it. Now what do you do with the push? Now push will basically have to do an append, right? So self dot in stack, and we were appending it to the in stack. We don't append to the out stack. Okay, so append. What will you append? It is given here. X is the integer, so you just write an X. Okay, next will be your pop. But before popping, you should make sure that they move from your in stack to the out stack. Okay, if your out stack is empty, then you can't pop anything. So you need to call the move function, and it will finally return your self dot out stack, right? So out stack dot pop. Okay, that is all that you have to do in the uh, pop. The next one is peak. Now in peak also, what you need to check that you first move that value. Okay, you need to check that self dot move. Then you will do a return on self dot, where do you peak? You peak in the out stack, correct? So out stack. And how you going to peak? You're going to check if the last index is empty or not. Okay, you always peak the last index. Okay, and the last one is to check if it is empty or not. So definitely you have to do return not of self dot in stack. Okay, you need to check this, and it is not of self dot out stack. I mean, both of them has to be empty. Only then you have successfully created a what? A queue. Okay. Now, must be wondering what is move. So we will define a function called move. Okay. And in that we will write this, that if not in self dot out stack. Okay. If it is not an out stack, then while it is in your in stack, okay, what are you going to do? You have to keep appending self dot out stack with what? What will you append this with? With the values of your in stack, right? So you're going to append it with self dot in stack. Okay, in stack, and yeah, you're basically popping it. So you need to write that pop operation. Okay, got it. So if we go ahead and run this, we'll see what happens. Should work. Yep. So that is working. Okay, you can go ahead and submit this question. So basically, you are solving this. You are basically writing a code. You're writing the functions. You're making things work by writing different functions that have been asked you to complete. Okay, so these are a pretty common kind of thing that has become favorite to all mass recruiting companies. So I hope that this video was helpful and you have learned something new, and you are prepared for So to implement the queue using two stacks in Java, it's again same, pretty easy. The only difference would be you would just make these stacks as private. So one will be your in stack, the other will be your out stack, and both of them will be private. So let's call this like this, in stack. And suppose we have private. Why did I make it capital? Private stack integer, and it's called as the out stack. Okay, that's it. Now for the next one, that is my queue. So basically you are going to create new queues. So how will you do it? In stack is equal to new stack. Okay, that's it. And similarly for your out stack, you're going to just do it as new stack. All right. That is exactly how you're going to work in here. It's not complicated at all. And for the push, we are using the in stack. So you will go with in stack dot push. And what will you pass? You'll pass the variable x that is mentioned over here. Okay. Similarly for pop, what will you have? You will have the out stack, but before that, you need to make sure that you have moved them correctly. So you will use the move function and you're going to just return out stack dot pop. Okay. And similarly for peak, what are you going to just do in peak? Peak is same like your pop. So you have to move that first. Sorry. And once you move it, then you're going to just return out stack dot peak. Okay. Now, once this is done, what's the last one? Just to check whether it is empty or not. So how will you check if that is empty or not? You're going to just do return in stack. You're going to check both these stacks to be empty, right? So you will do is empty on in stack and also on the out stack. Stack dot is empty. Okay. Now you have one more function to write, that is the move function. How will you write or implement this move function? So if your out stack is empty, okay, if this is true, out stack dot is empty, we are calling that function. Okay, then what are you going to do? Then you will run a loop that while it's not in the in stack, okay, while not in stack is empty, that means it's not empty, it has some value. You're just going to push that into the out stack, but before pushing, you have to pop it from the in stack. So how do you write it? You will write out stack dot push because you're pushing it into the out stack. But before that, you have to pop it from the in stack. So in stack dot pop. Okay, that's it. And we'll go ahead and run this. Hopefully, this should be accepted. Oh, there's an extra, I guess. Yep, so that is accepted. That's working fine. We'll go ahead and submit this. Perfect. Okay, so that's all that you needed to do. Okay.